Hello there, and welcome. Tonight I want to take you somewhere special, somewhere beyond the gentle glow of your bedside lamp, beyond the familiar walls that surround you, out past the atmosphere that cradles our world like a cosmic blanket. We're going to drift together through the vast, quiet ocean of space to ponder a visitor that came calling not so long ago. A visitor whose brief passage through our corner of the universe might have done something rather extraordinary, something we're only beginning to understand. It's a question that might seem impossible at first, perhaps even a bit fanciful. But stay with me, because what if, just maybe, a comet named 3I Atlas didn't just pass through our solar system, but gently, almost imperceptibly, altered the very timeline of our future? You see, we live our lives on this small blue marble, going about our days, our routines, our dreams and worries, rarely pausing to consider that we're actually hurtling through space at tremendous speeds, part of a cosmic dance that's been going on for billions of years. And in this dance, we occasionally have partners who sweep close, visitors from the depths of time and space who bring with them stories from the earliest days of our solar system. Comet 3I Atlas was one such visitor, and tonight, we're going to explore the possibility that its visit was more than just a celestial flyby, that perhaps, in ways we're only beginning to imagine, it left its mark on our world's destiny. Now, I know what you might be thinking as you settle into your pillow, as you pull the covers up just a little bit closer. How could a comet, a ball of ice and dust no bigger than a mountain, possibly alter the timeline of an entire planet? It seems almost too fantastic to consider, doesn't it? And yet, as we'll discover together over the next few hours, the universe operates on principles far more subtle and interconnected than we often realize. Every gravitational tug, every particle exchanged, every photon of light that touches our atmosphere carries with it the potential for change, for influence, for the gentle reshaping of what's to come. Consider this for a moment as you let your breathing slow, as you let the tensions of the day begin to melt away. If you compress the entire history of our universe, all 13.8 billion years of it, into a single day, our solar system wouldn't form until about 4:30 in the afternoon. Life on Earth wouldn't appear until around 5:30 p.m. And humans? We wouldn't show up until the very last fraction of the very last second before midnight. In this compressed timeline, Comet 3I Atlas's visit would be so recent, so fresh, that it would be like something that happened less than a heartbeat ago. And perhaps, just perhaps, we haven't yet felt all the ripples from that cosmic heartbeat. The story we're about to explore together isn't one of catastrophe or alarm. No, this is a story of wonder, of possibility, of the gentle mysteries that surround us every moment of every day. It's about how the smallest interactions can have the most profound consequences, how a whisper from space might echo through time in ways we never expected. As we journey together through this cosmic tale, we'll meet the scientists who first spotted this interstellar visitor. We'll learn about the ancient ice it carried from the dawn of our solar system, and we'll contemplate what it might mean for our future that this particular comet, at this particular moment, chose to grace our skies. You know, there's something deeply comforting about contemplating our place in the cosmos on a quiet night like this. It reminds us that we're part of something so much larger than ourselves, that we're connected to every star you can see through your window and countless more that lie beyond the reach of our eyes. Every atom in your body, every molecule of air you're breathing right now was forged in the heart of a star that lived and died long before our sun was born. We are, quite literally, made of stardust, and when visitors like Comet 3I Atlas come calling, they're not really strangers at all. They're distant cousins, fellow travelers in this grand cosmic journey. As we begin our exploration, I want you to imagine yourself floating gently above the Earth, looking down at our beautiful blue world as it turns slowly in the darkness. From up here, there are no borders, no divisions, just one precious sphere of life suspended in the void. Now cast your gaze outward. past the moon with its familiar craters and mountains, past Mars glowing like a ruby in the darkness, out beyond the asteroid belt where millions of rocky fragments tumble in their ancient orbits. Keep going, past mighty Jupiter with its swirling storms, past ringed Saturn in all its glory, past the ice giants Uranus and Neptune at the edge of what we once thought was the boundary of our solar system. But we're not stopping there. No, we're going further still, out into the Kuiper belt where Pluto and its companions dance in the darkness, and then beyond even that, into the vast sphere of the Oort cloud. This is where our story truly begins, in this enormous shell of icy bodies that surrounds our solar system like a cosmic snow globe. The Oort cloud extends nearly a light year from our sun, so far that if you were standing there right now, our sun would look like just another star in the sky. Perhaps a bit brighter than the others, but certainly not the blazing orb that warms our days. It's from this distant, frozen realm that Comet 3I Atlas began its journey toward us, though calling it a journey might not quite capture the epic nature of its voyage. This wasn't a trip of days or years or even centuries. This comet had been travelling for potentially millions of years, carrying with it pristine material from the very birth of our solar system, or perhaps, and this is where things get particularly intriguing, from another star system entirely. You see, the designation 3I tells us something special about this visitor. The I stands for interstellar, meaning this comet might not have originated in our Oort cloud at all, but could have been a wanderer between the stars, a cosmic messenger from another part of our galaxy. Imagine that for a moment. As you lie there in the comfort of your bed, think about a chunk of ice and rock that has been sailing through the empty darkness between stars for longer than humans have existed, longer than complex life has flourished on Earth, perhaps longer than our planet has been here at all. And then, by pure cosmic chance, or perhaps, as we'll explore, by some deeper pattern we don't yet understand, its path brought it sweeping through our solar system at precisely this moment in our history. The discovery of Comet 3 Atlas itself is a testament to how far we've come in our ability to peer into the darkness and spot these cosmic visitors. It was first detected in December 2019 by the Atlas Survey, which stands for Asteroid Terrestrial Impact Last Alert System. Now, don't let that name alarm you. Atlas wasn't warning us of any danger from this particular comet. Rather, it's one of several automated telescope systems that continuously scan the skies, taking images night after night, comparing them to spot anything that moves against the background of stars. It's like a cosmic security camera, quietly watching, waiting, recording the comings and goings in our celestial neighbourhood. When Atlas first spotted this comet, it was still far from the sun, just a faint smudge of light barely distinguishable from the countless stars in the background. But there was something about its trajectory, about the way it was moving, that immediately caught the attention of astronomers around the world. This wasn't following the typical path of a comet from our own Oort cloud. No, this was something different, something special. As more observations came in, as telescopes around the world turned to track this mysterious visitor, the excitement in the astronomical community began to build. You have to understand, for those who study the cosmos, the arrival of an interstellar visitor is like finding a message in a bottle that's been floating in the ocean for eons. It's a chance to study material that formed under completely different conditions, around a different star, in a different part of our galaxy. Every spectrum we capture, every photograph we take, every measurement we make could tell us something new about the universe beyond our solar system. And Comet 3I Atlas promised to be particularly revealing because, unlike some other interstellar objects we've detected, this one was going to pass relatively close to the Sun, where the heat would cause it to become active, to develop a coma and tail that would reveal its composition. As winter turned to spring in 2020, astronomers watched with growing anticipation as the comet approached. Based on its initial brightness and trajectory, some predictions suggested it might become visible to the naked eye, perhaps even spectacular, a cosmic display for all humanity to witness. Can you imagine that? In a year that would prove to be one of the most challenging in recent human history, the universe seemed to be preparing to offer us a gift, a reminder of the beauty and wonder that exists beyond our earthly troubles. But the cosmos, as we're constantly reminded, doesn't always follow our scripts or meet our expectations. As Comet 3I Atlas drew closer to the Sun, something unexpected began to happen. Instead of brightening steadily as most comets do when they approach our star, Atlas began to fragment. Through telescopes, astronomers watched as what had been a single, cohesive object began to break apart, splitting into multiple pieces like a cosmic snowball crumbling in slow motion. It was both disappointing and fascinating. Disappointing because it meant the comet wouldn't put on the spectacular show many had hoped for, but fascinating because this fragmentation was telling us something important about the comet's structure and composition. Think about what this means for a moment. Here was an object that had survived millions, perhaps billions of years journeying through space, enduring the cold vacuum, cosmic radiation, and who knows what else, only to fall apart as it approached our sun. It's almost poetic, isn't it? Like an ancient manuscript that crumbles the moment it's exposed to air, or a deep-sea creature that can't survive being brought to the surface. The very act of observing, of bringing this cosmic visitor into the warmth and light of our inner solar system, was causing it to transform, to reveal itself in ways we couldn't have predicted. Now, this is where our story takes a particularly intriguing turn, because while the fragmentation of Comet 3I Atlas might have been disappointing, for those hoping for a spectacular light show, it actually made the comet far more interesting from a scientific perspective. You see, when a comet breaks apart, it exposes fresh material from its interior, material that has been protected from space weathering for eons. It's like cracking open a time capsule, revealing pristine samples from the earliest days of wherever this comet originated. And here's something to contemplate as you drift deeper into relaxation. Every fragment that broke off from Comet 3I Atlas, every particle of dust and ice that was released didn't just disappear. These particles spread out along the comet's orbit, creating a trail of cosmic debris stretching for millions of miles. Some of this material would be swept up by the solar wind and carried out to the edges of our solar system, but some of it, and this is where things get particularly interesting, some of it would remain in orbits that intersect with Earth's path around the Sun. This means that right now, as you lie there listening to these words, our planet might be passing through an invisible cloud of particles from Comet 3I Atlas. These particles are far too small to see, most of them no bigger than grains of sand, many as small as smoke particles, but they're there, gently raining down through our atmosphere, adding their ancient material to our world. It's happening so slowly, so subtly, that we don't even notice it, but it's happening nonetheless. Consider what this means. Material that formed around another star, that has been traveling through interstellar space for longer than our species has existed, is now becoming part of Earth. It's mixing with our atmosphere, settling onto our oceans, perhaps even being incorporated into living things. In a very real sense, Comet 3I Atlas hasn't just passed by our world, it's become part of it. And if this material carries with it any unique properties, any unusual isotopes or molecular structures, these too are now part of our planet's inventory. Scientists estimate that Earth gains about 40,000 tons of cosmic material every year from various sources: cosmic dust, micrometeorites, and yes, particles from comets. Most of this material is from our own solar system, but some of it, a small but significant percentage, comes from interstellar space. With the passage of Comet 3I Atlas, that percentage might have increased, even if just slightly. And in the grand scheme of cosmic time, even the slightest changes can have profound effects. Think about it this way. If you change the chemical composition of Earth's atmosphere by even a tiny fraction, you might alter weather patterns, change weather patterns, and you affect everything from ocean currents to the distribution of plant and animal life. These changes ripple outward, affecting human agriculture, migration patterns, the development of civilizations. It's the butterfly effect on a cosmic scale, where a comet breaking apart millions of miles away could theoretically influence the course of human history. But we're not talking about dramatic, immediate changes here. No, the influence of Comet 3I Atlas, if it exists at all, would be far more subtle. Perhaps it's in the form of new chemical compounds in our upper atmosphere that affect how sunlight is absorbed or reflected. Perhaps it's in the form of organic molecules that seed new chemical reactions in our oceans. Or perhaps, and this is where we venture into the realm of beautiful speculation, it's in the form of information. Cosmic information encoded in the very structure of the material that this interstellar visitor brought to our world. You see, one of the most profound questions in astronomy is whether the building blocks of life are unique to Earth or whether they're common throughout the universe. We know that organic molecules, the carbon-based compounds that form the basis of all life as we know it, can form in space. We've detected them in interstellar clouds, in the atmospheres of other planets, and yes, in comets. Some scientists even theorize that life on Earth might have been seeded by organic material delivered by comets billions of years ago. It's called panspermia, and while it remains a hypothesis, it's one that gains a bit more credibility every time we discover complex organic molecules in space. Now, I'm not suggesting that Comet 3 Atlas brought life to Earth. We're about 3.8 billion years too late for that. But what if it brought something else? What if it brought new types of organic molecules, ones that could interact with Earth's existing chemistry in novel ways? What if these molecules are even now working their way through our biosphere, creating new possibilities for chemical reactions, new pathways for evolution, new potentials that didn't exist before? It's a thought that makes you realize how interconnected everything in the universe truly is. We tend to think of Earth as a closed system, separate from the cosmos, protected by our atmosphere like a terrarium floating in space. But the truth is far more beautiful and complex. Earth is constantly exchanging material with space. We lose atmosphere to the solar wind, and we gain material from cosmic impacts. We're not separate from the universe. We're an active participant in it, constantly changing and being changed by our cosmic environment. As you contemplate this, let your mind wander to the ancient civilizations that watched comets with a mixture of awe and fear. To them, comets were omens, messages from the gods, harbingers of change. They didn't have our scientific understanding, our telescopes and spectrometers, but perhaps they intuited something we're only now beginning to understand with our modern science, that these cosmic visitors really do bring change, just not in the way they imagined. The ancient Chinese astronomers kept meticulous records of comets, documenting their appearances with remarkable accuracy. They called them broom stars because of their tail-like appearance, and they believed they swept away the old to make way for the new. In a sense, they weren't wrong. Every comet that passes through our inner solar system does sweep away some of the old, carrying away solar wind particles, disrupting the orbits of small bodies, and yes, depositing new material that becomes part of our world. The Babylonians too watched comets carefully, incorporating them into their complex astrological systems. They believed that the appearance of a comet could influence the fate of kingdoms, the success of harvests, the birth of important figures. And while we might smile at their superstitions, consider this. If comets do indeed deliver material that subtly alters our planet's chemistry, couldn't they, in a very indirect way, influence all of those things? Even in more recent history, comets have been seen as agents of change. Halley's Comet, which returns every 76 years, has been linked to numerous historical events, from the Norman conquest of England in 1066 to the birth of Mark Twain in 1835. Of course, these are coincidences, aren't they? Or are they? If we accept that comets can deliver material that affects Earth's environment, even slightly, then perhaps their influence on human history isn't entirely imaginary. But let's return to our specific visitor, Comet 3I Atlas, and consider what makes it particularly special. Unlike Halley's Comet, which is a regular visitor, Trapped in an orbit around our Sun, 3I Atlas was a one-time guest. It came from interstellar space, made its single pass through our solar system, and is now heading back out into the void, never to return. This means that whatever influence it might have had on our world, whatever material it delivered, whatever changes it might have initiated, they're unique, unrepeatable. There's something profound about that, isn't there? In the entire history of our planet, in the billions of years that Earth has existed, Comet 3I Atlas passed by exactly once, at exactly this moment in our development as a species. A few million years earlier, and there would have been no humans to observe it. No telescopes to track it, no scientists to analyze its spectrum. A few million years later, and who knows what humanity might look like, or whether we'll even still be here. The timing of this cosmic encounter raises interesting questions about probability and destiny. What are the odds that an interstellar comet would pass through our solar system at precisely the moment when we've developed the technology to detect and study it, but before we've developed the ability to actually visit it? It's a narrow window in cosmic terms, perhaps just a few centuries out of billions of years. Is this pure coincidence, or is there something more at play? Some physicists and philosophers have proposed what's known as the anthropic principle, the idea that the universe must be compatible with the conscious life that observes it. In other words, we observe the universe the way it is because if it were different, we wouldn't be here to observe it. It's a bit of a circular argument, but it raises interesting questions about the role of consciousness in the cosmos. Could it be that Comet 3I Atlas appeared precisely when it did because that's when conscious beings on Earth were ready to observe it and ponder its significance? Now, I know that might sound a bit too mystical for some, a bit too much like those ancient astrologers reading omens in the sky. But consider this. Quantum mechanics, our most successful theory of the microscopic world, tells us that observation plays a fundamental role in reality. The act of observing a quantum system causes it to collapse from a superposition of states into a single, definite state. Could something similar be happening on a cosmic scale? Could our observation of Comet 3I Atlas have somehow influenced its behavior, caused it to fragment when it did, release precisely the material that it did? It's a question that takes us to the very edge of what science can currently address, into the realm where physics meets philosophy, where the material meets the mysterious. And perhaps that's appropriate for a discussion about a comet that might have altered our timeline. Because timelines, after all, are not just about physical events. They're about possibilities, potentials, the paths taken and not taken. Speaking of paths, let's consider for a moment the trajectory that brought Comet 3I Atlas to our solar system. Based on its orbit, astronomers were able to work backward, to trace where this cosmic visitor came from. And the answer is both specific and wonderfully vague. Specific because we can point to a general direction in the sky, toward the constellation of Cassiopeia. Vague because we have no idea how far the comet travelled from that direction, which star system it might have originated from, or how long it's been wandering through interstellar space. It could have come from a star system just a few light years away, perhaps Proxima Centauri, our nearest stellar neighbour. Or it could have come from much farther, from stars we can barely see with our most powerful telescopes, from regions of our galaxy that we've never explored, even with our robotic probes. The comet itself isn't talking, or rather, it's speaking in a language we don't fully understand yet, a language written in the isotopes of its ice, the minerals of its dust, the organic molecules that it carried. This uncertainty about the comet's origin adds another layer to our mystery, because if we don't know where it came from, we can't know what it might have brought with it. Every star system is unique, with its own chemical signature based on the composition of the original nebula from which it formed. A comet from a system with a different mix of elements might carry exotic materials that don't naturally occur in our solar system. These materials, even in tiny quantities, could act as catalysts, triggering new chemical reactions, opening up new possibilities. Imagine, for instance, that Comet 3I Atlas originated from a star system where the initial nebula had a slightly different ratio of heavy elements. Perhaps there was more iridium, or more selenium, or some rare isotope that's almost non-existent in our solar system. Now imagine that some of this material made its way to Earth's surface, where it was incorporated into the soil, taken up by plants, consumed by animals, eventually making its way into the human food chain. Could such exotic elements affect biological processes? Could they influence neural activity, alter DNA expression, trigger mutations? These are not idle speculations. We know that trace elements can have profound effects on biological systems. Selenium, for instance, is essential for human health in tiny amounts, but toxic in larger doses. Lithium, in minute quantities, can affect mood and is used to treat bipolar disorder. If Comet 3I Atlas delivered even tiny amounts of unusual elements or isotopes, the effects could ripple through Earth's biosphere in ways we can't predict. But perhaps we're thinking too small, too locally. Perhaps the real impact of Comet 3I Atlas isn't in the material it delivered to Earth, but in the gravitational perturbations it caused as it passed through our solar system. Every object with mass exerts a gravitational pull on every other object, and while a comet's mass is tiny compared to planets, its effects are not zero. As 3I Atlas swept through the solar system, it would have tugged ever so slightly on every planet, every asteroid, every speck of dust in its vicinity. These gravitational nudges would be incredibly small, imperceptible to our instruments. But chaos theory tells us that in complex systems, even the tiniest changes can have large effects over time. It's the butterfly effect again, where a butterfly flapping its wings in Brazil could theoretically trigger a tornado in Texas. In the solar system, a tiny change in an asteroid's orbit could, over millions of years, determine whether it eventually collides with Earth or misses us entirely. Consider this scenario. Somewhere in the asteroid belt there's a rock, maybe a few hundred meters across, that was given the tiniest of nudges by Comet 3I Atlas's gravity. This nudge changed its orbit by a fraction of a degree, an amount so small that we couldn't measure it even if we knew where to look. But over time, as this asteroid continues to orbit the Sun, that tiny change accumulates. Other gravitational influences, from Jupiter, from Mars, from other asteroids, amplify the effect, and perhaps in 1,000 years, or 10,000, or 1,000,000, this asteroid's path will intersect with Earth's in a way it wouldn't have without that initial nudge from our interstellar visitor. Now, I'm not trying to alarm you with tales of future asteroid impacts. Remember, we're exploring possibilities, not certainties, and the universe is full of checks and balances that tend to maintain stability over chaos. But it illustrates an important point. The effects of Comet 3I Atlas's passage might not be apparent for a very long time. We might be living in the immediate aftermath of a cosmic event whose true significance won't be realized for generations, centuries, or even longer. This brings us to a fascinating aspect of time and causality in the universe. We tend to think of cause and effect as immediate. You flip a switch, the light turns on. But in cosmic terms, cause and effect can be separated by vast spans of time. A star explodes today, and its light doesn't reach us for millions of years. A comet passes through our solar system, and its effects might not manifest for millennia. We're living in a universe where the past, present, and future are all interconnected in ways that challenge our everyday understanding of time. And speaking of time, let's consider when Comet 3I Atlas made its appearance. It was discovered in December 2019, just as humanity was about to enter one of the most transformative periods in recent history. Within months of the comet's discovery, the world would be gripped by a pandemic that would change how we work, how we socialize, how we think about our place in the world. Is this timing purely coincidental, or could there be some connection? Now, I want to be absolutely clear here. I'm not suggesting that Comet 3I Atlas caused the pandemic. That would be venturing into the realm of pseudoscience and conspiracy theories, which is not where we're going with this exploration. The virus that causes COVID-19 has been thoroughly studied, its origins traced through genetic analysis, its evolution tracked through scientific research. But what I am suggesting is that the comet's appearance at this particular moment in human history adds an interesting layer to our story. You see, throughout history, comets have often appeared during times of great change, times when humanity was at a crossroads. This could be pure coincidence, of course. Comets are passing through our solar system all the time, and humans are always experiencing some form of change or crisis. But there's something poetic about the idea that, as we were about to enter a period that would fundamentally alter our relationship with technology, with nature, with each other, a visitor from interstellar space was passing overhead, perhaps leaving its own subtle mark on our world. The pandemic forced humanity to pause, to reflect, to reconsider our priorities and our future. It accelerated technological development in some areas, while highlighting our vulnerabilities in others. It changed how we think about global cooperation, about science, about our relationship with the natural world. And through it all, particles from Comet 3I Atlas were gently raining down through our atmosphere, adding their ancient material to our world. Could these particles have influenced anything about how the pandemic unfolded? Almost certainly not in any direct way. But in the grand tapestry of cause and effect that connects all things in the universe, who's to say that there isn't some thread, however thin, connecting these two events? Perhaps the comet's particles affected atmospheric chemistry in subtle ways that influenced weather patterns, which affected human behavior, which affected how the pandemic spread. The connections might be so tenuous, so indirect, that we could never trace them. But that doesn't mean they don't exist. This is the beauty and the mystery of living in an interconnected universe. Everything influences everything else, even if the influences are too small or too slow for us to perceive. We're all part of a cosmic web of causality that stretches from the Big Bang to the heat death of the universe, and every event, no matter how small, sends ripples through this web. As you lie there, perhaps you can feel yourself as part of this vast web. Your breath mingles with the atmosphere that contains particles from Comet 3I Atlas. The gravity of your body, tiny as it is, pulls on every object in the universe, just as every object in the universe pulls on you. You're not separate from the cosmos, you're an integral part of it, a conscious point in the universe where it becomes aware of itself. The fragmentation of Comet 3I Atlas offers us a beautiful metaphor for this interconnectedness. When the comet broke apart, it didn't disappear. It transformed, spreading its material across a wider area, increasing its surface area, its ability to interact with its environment. In a sense, it became more present, more influential, by becoming less cohesive. Its destruction was also a form of creation, a transformation from one state to another. This is how the universe works, through constant transformation, constant exchange. Stars die and seed space with heavy elements that become part of new stars, new planets, new life. Comets break apart and deliver their material to worlds throughout the galaxy. And on at least one of those worlds, that material becomes part of conscious beings who can look up at the night sky and wonder about their cosmic origins. The study of Comet 3I Atlas involved astronomers from around the world working together, sharing data, pooling their resources to understand this interstellar visitor. Telescopes in Hawaii, Chile, Spain, and dozens of other locations all turn their gaze to this small, fragile object. Space telescopes like Hubble captured images of its fragmentation. Amateur astronomers with backyard telescopes contributed observations. It was a beautiful example of humanity coming together to understand something larger than ourselves. And what did we learn? We learned that the comet was rich in carbon, suggesting an origin in the outer regions of whatever system it came from. We learned that it was fragile, held together loosely, what astronomers call a rubble pile. We learned that it was ancient, probably billions of years old, a fossil from the early days of star formation somewhere in our galaxy. Each piece of data, each observation, added to our understanding not just of this particular comet, but of comets in general, of the processes that shape our solar system and others. But perhaps the most important thing we learned is how much we still don't know. Every answer raised new questions. Why did the comet fragment when it did? What determined its exact composition? How many other interstellar visitors passed through our solar system undetected? These questions remind us that we're still in the early days of our cosmic exploration, still children trying to understand a universe that's vast beyond imagination. As we move deeper into our contemplation of Comet 3I Atlas and its possible effects on Earth's timeline, let's consider the nature of time itself. We experience time as a linear progression, moment following moment, cause preceding effect. But physics tells us that time is far stranger than our everyday experience suggests. Einstein's relativity shows us that time is relative, that it flows at different rates depending on gravity and velocity. Quantum mechanics hints at even stranger possibilities, where the future might influence the past, where multiple timelines might exist simultaneously until observation collapses them into one. What if Comet 3I Atlas exists at an intersection of timelines? What if its passage through our solar system represents a branching point, where our future split into multiple possibilities? In one timeline, the comet passed without incident, leaving no trace. In another, the one we're experiencing, it fragmented, spreading its material, subtly altering the course of events. And perhaps in yet another timeline, it impacted Earth directly, causing massive changes to our world. This might sound like science fiction, but it's based on serious interpretations of quantum mechanics. The many worlds interpretation, proposed by physicist Hugh Everett, suggests that every quantum event causes the universe to split into multiple parallel realities. If this is true, then the fragmentation of Comet 3I Atlas, which involved countless quantum events as molecular bonds broke and reformed, would have created countless parallel timelines. We, of course, can only experience one timeline, the one we're in right now. But the existence of other timelines, other possibilities, adds a layer of depth to our contemplation. When we ask whether Comet 3I Atlas altered Earth's future timeline, we might really be asking, which timeline are we in? Are we in the timeline where its effects will be beneficial, neutral, or challenging? Are we in the timeline where humanity learned something crucial from studying this interstellar visitor? The ancient Greeks had two words for time, chronos and kairos. Chronos is clock time, the measurable progression of moments. Kairos is the right or opportune moment, time that's full of potential and meaning. The passage of Comet 3 Atlas through our solar system was a chronos event. It happened at a specific measurable time, but perhaps it was also a kairos event, a moment pregnant with possibility, a cosmic opportunity for transformation. As you drift deeper into relaxation, consider how many such moments might be happening all around us, all the time. Every particle of cosmic dust that enters our atmosphere, every photon of starlight that reaches Earth, every gravitational wave that passes through our planet. Each of these could be a tiny kairos moment, an opportunity for change, for evolution, for transformation. We're swimming in a sea of cosmic influences, most too subtle for us to detect, but all potentially significant in the grand scheme of things. The fragmentation of Comet 3I Atlas was observed in detail by the Hubble Space Telescope, that magnificent eye in the sky that has revolutionized our understanding of the universe. The images Hubble captured show the comet breaking into dozens of pieces, each fragment surrounded by its own small cloud of dust and gas. It's a haunting sight, like watching a dandelion seed head dispersing in slow motion, each seed carrying the potential for new growth. These fragments didn't all follow the same path. As the comet broke apart, each piece was given a slightly different velocity, a slightly different trajectory. Some fragments might have been ejected from the solar system more quickly, while others might linger, perhaps even being captured into long elliptical orbits, that will bring them back to the inner solar system in the distant future. Each fragment carries its own potential for influence, its own possible effects on the timeline. Think about what this means for the distribution of the comet's material. Instead of a single concentrated dose of interstellar material, we have a dispersed cloud spread across millions of miles of space. Earth might encounter this material not just once, but multiple times over the coming years, decades, even centuries. Each encounter would be subtle, probably undetectable, but potentially significant in aggregate. It's like the difference between taking medicine all at once versus taking it in small doses over time. The same amount of material can have very different effects depending on how it's delivered. The fragmentation of Comet 3I Atlas might have transformed what would have been a single brief encounter into an extended, gentle influence that will continue for generations. And what about the fragments that didn't come near Earth? They're still out there, carrying their interstellar material to other parts of the solar system. Some might have passed close to Mars, delivering material to our neighbouring planet. Others might have ventured out to the asteroid belt, or even to the moons of Jupiter and Saturn. Each delivery could potentially affect the chemistry of these worlds, possibly influencing future human exploration, or even the potential for life. Imagine future human colonists on Mars, perhaps a century from now, discovering unusual isotopes in the Martian soil, isotopes that match those found in the spectrum of Comet 3I Atlas. They might realize that they're standing on ground that contains material from another star system delivered by our interstellar visitor. It would be a tangible connection to the cosmos, a reminder that even Mars, like Earth, is constantly receiving gifts from the universe. Or consider Europa, Jupiter's ice-covered moon that likely harbours a liquid ocean beneath its frozen surface. If fragments from Comet 3I Atlas delivered organic molecules to Europa, could they influence any potential life that might exist in that hidden ocean? Could they provide new nutrients, new chemical possibilities, new evolutionary pressures? The effects might not be apparent for millions of years, but the seeds of change could be planted now. This is the thing about cosmic events. Their effects ripple outward in space and time in ways we can barely imagine. A comet passes through our solar system, and its influence spreads like ripples on a cosmic pond, affecting worlds, affecting futures, affecting possibilities we haven't even conceived of yet. As we contemplate these vast scales of space and time, it's natural to feel small, perhaps even insignificant. But I want to suggest a different perspective. Yes, we're small compared to the cosmos, brief compared to cosmic time, but we're also the universe becoming conscious of itself, able to observe, to wonder, to theorize about comets and timelines, and the nature of existence itself. In a very real sense, we're the cosmos contemplating itself, and that makes us profoundly significant. The fact that we can detect an interstellar comet, analyze its composition, track its trajectory, and ponder its implications is remarkable. It represents billions of years of evolution, thousands of years of human civilization, centuries of scientific development. We're the product of countless cosmic events, including perhaps the delivery of essential materials by ancient comets. And now we're able to observe and study new comets as they arrive, to be conscious witnesses to the ongoing evolution of our solar system. Comet 3I Atlas might have altered Earth's timeline, but we've also altered its timeline. By observing it, studying it, recording its passage, we've made it part of human history, part of our collective memory. In some future era, when humanity is spread throughout the solar system, or even to other stars, the data we collected about this comet might prove crucial for understanding something we can't even imagine yet. Perhaps future scientists will discover that interstellar comets like 3I Atlas are carriers of information, cosmic messages encoded in their chemical composition or their orbital characteristics. Perhaps they'll realize that these visitors are part of a galactic communication network, a slow but steady exchange of material and information between star systems. What seems random to us now might be revealed as part of a larger pattern, A cosmic conversation that's been going on for billions of years. Or perhaps the significance of Comet 3I Atlas is simpler and more profound. Perhaps its gift to us was wonder itself, the opportunity to look up and realize that we're not alone in the universe, that we're part of a vast interconnected cosmos where material and energy and information flow between stars like blood flows through a body. Perhaps its fragmentation was a reminder that nothing in the universe is permanent, that everything is in constant transformation, and that's not a cause for sadness, but for celebration of the dynamic, ever-changing nature of existence. The ghostly visitor has come and gone, leaving us with more questions than answers, more mysteries than certainties. But that's as it should be. The universe would be a boring place if we understood everything, if there were no more mysteries to explore, no more questions to ask. Comet 3 Atlas has given us the gift of wonder, the gift of possibility, the gift of knowing that there's still so much we don't know. As you continue to relax, to let these thoughts wash over you like gentle waves, consider that you too are a kind of comet, a temporary aggregation of matter and energy passing through space and time. Like Comet 3 Atlas, you're made of ancient material, atoms forged in the hearts of stars, molecules that have been part of countless other forms before becoming you. And like the comet, you're leaving traces of yourself wherever you go, influencing the world in ways both obvious and subtle, altering timelines with every choice you make, every action you take, every thought you think. The water in your body has been through countless cycles, has been rain and river and ocean, has been ice in ancient glaciers and vapor in prehistoric skies. The carbon in your cells has been part of rocks and trees and dinosaurs and stars. You're not separate from the cosmic story. You're a chapter in it, a unique arrangement of universal material that has temporarily come together to form something capable of consciousness, of wonder, of love. And just as Comet 3 Atlas brought material from another star system to our world, you bring your own unique perspective, your own contributions, your own influences to the grand story of existence. Every person you meet, every idea you share, every kindness you offer ripples outward, affecting timelines in ways you'll never fully know. You're part of the cosmic web, a node in the vast network of cause and effect that connects all things. The fragmentation of the comet reminds us that endings are also beginnings, that destruction is also creation. When something breaks apart, it doesn't disappear, it transforms, becomes something new, continues its journey in a different form. The ice and dust that made up Comet 3I Atlas is still out there, still travelling, still influencing, just in a more dispersed way. And perhaps that dispersion allows for more interactions, more influences, more possibilities than if the comet had remained whole. In our own lives, we experience similar transformations. Relationships end and new ones begin. Dreams shatter and new visions emerge. We ourselves are constantly changing. Ourselves replacing themselves, our thoughts evolving, our understanding deepening. We're not the same person we were yesterday, and tomorrow will be different still. Like the comet, we're in constant transformation, constantly exchanging material and energy and information with our environment. The timeline that Comet 3 Atlas might have altered isn't just Earth's timeline, it's our timeline, humanity's timeline, your timeline. Every cosmic event, no matter how distant, is part of our story because we're part of the cosmos. The atoms in your right hand might have come from a different star than the atoms in your left hand. You're a collection of cosmic travelers, temporarily assembled into the pattern that is you, participating in the grand adventure of existence. As we prepare to move deeper into our exploration, to consider the nature of time itself and how a comet might ripple through it, take a moment to appreciate the profound mystery of this moment. Right now, as you lie there, you're on a planet that's spinning at 1,000 miles per hour, orbiting a star at 67,000 miles per hour, which is itself orbiting the galactic center at 514,000 miles per hour, and yet you feel still, at peace, at rest. This is the miracle of relative motion, of being part of a system so vast and so balanced that tremendous movement feels like perfect stillness. Somewhere out there, Comet 3I Atlas continues its journey, its fragments spreading ever wider, carrying their interstellar material to new destinations. Some pieces might eventually leave our solar system entirely, returning to the interstellar void from which they came. Others might find new homes, might become part of other worlds, other stories, and some, just maybe, have already found their way to Earth, have already begun their subtle work of alteration, of influence, of transformation. The story of this ghostly visitor is far from over. In fact, it might just be beginning. The effects of its passage, if they exist, might not become apparent for years, decades, centuries, or even longer. We're living in the immediate aftermath of a cosmic event whose significance we can only guess at, whose influences we can only imagine, and that uncertainty, that mystery is part of what makes existence so wonderfully, beautifully complex. Every night, as Earth turns and new stars become visible, as meteors streak across the sky and cosmic dust settles gently through our atmosphere, the universe is writing new chapters in the story of our world. Comet 3I Atlas was one sentence in that story, perhaps a crucial one, perhaps a footnote we don't yet know. But by observing it, by studying it, by wondering about it, we've made it part of our story, part of the human narrative of trying to understand our place in the cosmos. The instruments that detected the comet, the computers that calculated its orbit, the minds that pondered its significance, these are all products of Earth's evolution, of the long chain of cause and effect that stretches from the first self-replicating molecules to conscious beings capable of detecting visitors from other star systems. In a sense, Earth developed eyes to see into space, and one of the things those eyes saw was Comet 3 Atlas. The universe observing itself through us observed this interstellar visitor, and in that observation, new possibilities were born. What those possibilities are, we can only imagine. Perhaps the comet's material will be incorporated into new life forms, contributing to Earth's ongoing evolution. Perhaps its gravitational influence will prevent or cause some future cosmic impact. Perhaps its study will lead to scientific breakthroughs we can't yet envision. Or perhaps its greatest gift was simply to remind us that we're part of a larger story, a cosmic narrative that transcends our daily concerns and connects us to the stars. As you drift deeper into relaxation, feeling the gentle pull of sleep beginning to embrace you, remember that you're resting on a world that's constantly receiving gifts from the cosmos. Every moment, particles from space are joining our world, becoming part of our air, our water, our soil, ourselves. We're not isolated, we're connected to everything, part of the eternal exchange of matter and energy that keeps the universe dynamic and alive. The story of Comet 3I Atlas is also the story of time, of how past, present, and future interweave in ways that challenge our everyday understanding. The comet's journey began perhaps billions of years ago, in the stellar nursery where its parent star was born. Its material carries the history of that time, frozen records of conditions that no longer exist. When we study such objects, we're literally looking back in time, seeing the universe as it was, not as it is. But the comet also represents the future, the possibilities that its material and influence might create. Seeds planted now that might not germinate for millennia, changes so subtle that they are imperceptible, but that accumulate over time into significant alterations. The future timeline that the comet might have altered isn't fixed. It's fluid, full of potential, shaped by countless influences, including, perhaps, this one small, fragile visitor from the stars. Time, as physicists understand it, isn't the simple, linear progression we experience. In Einstein's universe, time and space are interwoven into space-time, a four-dimensional fabric that can be warped by gravity, stretched by velocity. Near massive objects, time runs slower. At high speeds, time dilates, and at the quantum level, time might not even have a clear direction, with future events potentially influencing past ones through quantum entanglement and retrocausality. What if comets like 3I Atlas are temporal messengers, carrying not just material from other places but from other times? What if the ice and dust of the comet contains information about the future as well as the past, quantum patterns that influence probability, that nudge events in certain directions? It's a wild speculation, far beyond current science, but in the quiet of the night, in the space between waking and sleeping, such speculations seem less impossible and more like glimpses of a deeper truth we're not yet ready to fully understand. The fragmentation of the comet could be seen as a temporal event as much as a spatial one. When the comet broke apart, it didn't just spread its material across space, it spread its influence across time. Each fragment follows its own timeline now, will have its own effects, its own story. Some fragments might influence events next year, others might not have their effects felt for centuries. The comet's influence has been temporally distributed, spread across the future like seeds waiting for the right conditions to grow. Consider how this reflects the nature of causality in our universe. We tend to think of cause and effect as immediate and local. You push something, it moves. But in reality, causality can be non-local and non-immediate. A quantum event here can instantly affect an entangled particle on the other side of the universe. A gravitational wave from colliding black holes billions of light years away can slightly squeeze and stretch Earth, and a comet passing through our solar system can set in motion chains of events that won't conclude for eons. This is the kind of universe we inhabit, one where everything is connected across vast distances and times, where the flutter of a butterfly's wings really can influence weather patterns on the other side of the world, where a comet from another star system really might alter the timeline of our entire planet. It's a universe that's far stranger, far more interconnected, far more wonderful than our ancestors could have imagined. The scientists who studied Comet 3I Atlas used instruments that themselves represent a kind of time travel. The light from the comet took minutes to reach Earth, so when astronomers observed it, they were seeing it as it was in the past, not as it was in their present moment. The radio signals from spacecraft observing the comet took time to travel back to Earth. Even the computers processing the data introduced tiny delays. In a sense, our entire understanding of the comet is based on information from the past, assembled into a picture that we hope represents truth. But what is truth when it comes to something like a comet's influence on a timeline? We can measure its mass, its velocity, its composition, but can we measure its significance? Can we quantify its impact on the future? These are questions that science struggles with because they involve not just what is, but what might be, what could be, what will be. They require us to think not just about particles and forces, but about possibilities and potentials. The ancient concept of weird from Norse mythology might be relevant here. Weird is often translated as fate, but it's more complex than that. It's the idea that past, present, and future are all interwoven, that actions in the past create patterns that influence the future, but that the future also reaches back to influence the present. It's a non-linear understanding of time that quantum physics is only now beginning to explore scientifically. In the context of weird, Comet 3R Atlas's passage through our solar system would be seen as a significant weaving in the fabric of reality, a moment where threads from distant places and times came together to create new patterns. The fragmentation of the comet would be like the splitting of a thread, creating multiple new possibilities, multiple potential futures, and we, observing and contemplating this event, are also part of the weaving, our consciousness adding its own threads to the pattern. This brings us to an interesting question about consciousness and its role in shaping reality. If observation plays a fundamental role in quantum mechanics, causing wave functions to collapse into definite states, what role did our observation of Comet 3 Atlas play in its story? Did our watching, our measuring, our wondering about it somehow influence its behavior or its effects? It's a question that takes us to the edge of science and philosophy, to the place where the material and the mental meet. Some interpretations of quantum mechanics suggest that consciousness is necessary for physical reality to manifest, that without observers, the universe would exist only as a sea of possibilities, never collapsing into actual events. If this is true, then our observation of the comet wasn't just passive watching, it was active participation in the creation of reality. But even if we take a more conservative view, one that doesn't require consciousness to have such a fundamental role, we can still see how our awareness of the comet changes its significance. Before we detected it, Comet 3i Atlas was just another piece of ice and rock moving through space. But once we observed it, studied it, named it, it became part of human culture, part of our collective story. It gained meaning beyond its physical properties, and meaning, while not physical, can have physical effects. The meaning we assign to events influences our behavior, our decisions, our future actions. If studying Comet 3i Atlas inspires a young person to become an astronomer, if it leads to new technologies for detecting interstellar objects, if it changes how we think about our place in the universe, then the comet has altered our timeline not through its physical properties but through its meaning, through what it represents to us. This is perhaps the most profound way that Comet 3i Atlas might have altered Earth's future timeline, not through the material it delivered or the gravitational perturbations it caused, but through the thoughts it inspired, the questions it raised, the wonder it evoked. Ideas, after all, can be more powerful than any physical force. They can reshape civilizations, redirect the course of history, transform how we see ourselves and our universe. As you lie there, drifting ever deeper into the peaceful realm between waking and sleeping, you're participating in this transformation of meaning into reality. Your contemplation of the comet, your wondering about its effects, your imagination of possibilities, these are all real events that have real effects on the world. Neurons fire in your brain, creating patterns that didn't exist before. These patterns influence your thoughts, your dreams, your future actions. And through you, the comet's influence spreads, ripples outward, becomes part of the larger pattern of cause and effect that shapes our world. The story of Comet 3i Atlas is still being written, not just by scientists analyzing data, but by everyone who looks up at the night sky and wonders about our cosmic visitors. Each moment of wonder, each question asked, each possibility imagined adds a new thread to the story. We're all co-authors of this cosmic tale, all participants in the ongoing creation of reality. And perhaps that's the most beautiful aspect of this whole mystery. We're not just passive recipients of cosmic influences, we're active participants in a universe that's constantly creating itself, constantly exploring new possibilities, constantly evolving towards something we can't yet imagine. Comet 3i Atlas was a reminder of this participation, a gentle tap on the shoulder from the cosmos saying, "Remember, you're part of something vast and wonderful and mysterious." The fragments of the comet continue their journey, some perhaps already beyond the orbit of Neptune, others possibly still lingering in the inner solar system. Each fragment carries its portion of the original comet's material, its share of the interstellar message, and somewhere perhaps one of those fragments is destined for something special, a future encounter with Earth or another world, a delivery of material that will prove significant in ways we can't predict, a continuation of the story that began billions of years ago in another star system. Time flows on, carrying us all toward futures we can't fully foresee. But perhaps, thanks to a ghostly visitor named 3i Atlas, that future is slightly different than it would have been, altered in subtle ways that might take centuries to become apparent. We're living in the wake of a cosmic event, surfing the ripples it created in the fabric of space-time, riding waves of possibility toward destinations unknown. The night deepens around you, and somewhere above, beyond the protective blanket of our atmosphere, the cosmos continues its eternal dance. Stars are being born and dying, planets are forming and evolving, and comets are carrying their ancient messages between the stars. We're part of this dance, made of star stuff, influenced by cosmic events, participants in the greatest story ever told, the story of the universe itself. As we prepare to explore even deeper mysteries to consider the nature of time and change and possibility, remember that you're not just learning about these things, you're experiencing them. Right now, in this moment, you're a conscious point in the universe where it becomes aware of itself, where it wonders about comets and timelines and the nature of existence. You're the universe investigating itself, and that makes you, in your own unique way, as significant as any comet, any star, any galaxy. The whisper of change that Comet 3I Atlas might have brought to our world is just one note in the vast symphony of cosmic influences that shape our reality. But sometimes, one note can change an entire melody. One whisper can redirect a conversation. One small change can alter the course of history. As you drift towards sleep, carried on waves of cosmic wonder, remember that you too are such a whisper, such a note, such a change. Your existence matters, your thoughts matter, your dreams matter, because you're part of the cosmic story, a unique and irreplaceable thread in the vast tapestry of existence. The science of the unseen stretches before us like an ocean of possibility, vast and deep and full of mysteries we're only beginning to fathom. As you settle deeper into comfort, letting the weight of the day dissolve into the softness beneath you, consider how much of our universe remains invisible to us, hidden not by distance or darkness, but by the limitations of our senses and our instruments. Comet 3I Atlas revealed itself to us through patient observation, through the careful accumulation of data points that slowly assembled into a picture of something remarkable. But what it revealed was only a fraction of its true nature, like seeing the shadow of something magnificent without ever glimpsing the thing itself. When astronomers first detected this interstellar visitor in December 2019, they were looking at light that had travelled millions of miles to reach their telescopes. Not just any light, but ancient light. Photons that had bounced off ice and dust that formed in another star system, perhaps billions of years ago. Think about that for a moment. The light entering those telescopes carried information across not just space but time, delivering messages from an era before Earth existed, from a place we may never visit, from conditions we can only imagine. Every photon was a tiny time capsule, a messenger from the deep past arriving in our present moment. The Atlas survey that discovered the comet uses 2 telescopes in Hawaii, each scanning the sky multiple times each night, taking hundreds of images that are then compared by sophisticated computer algorithms looking for anything that moves against the background of stars. It's a testament to human ingenuity that we can spot something as small and faint as a comet while it's still beyond the orbit of Mars. The comet appeared as just a few pixels of light, slightly brighter than the background, moving slowly across the field of view. From those few pixels, astronomers could calculate its orbit, estimate its size, predict its future path through our solar system. But the real magic began when other telescopes joined the observation campaign. Each telescope, each instrument, revealed different aspects of the comet's nature. Spectroscopes split the comet's light into its component wavelengths, revealing the chemical fingerprints of different molecules. Radio telescopes detected emissions from various gases sublimating off the comet's surface. Infrared telescopes peered through the dust to see the heat signature of the comet's nucleus. It was like examining an ancient manuscript with different types of light, each revealing hidden text, hidden meanings, hidden secrets. The spectroscopic analysis was particularly revealing. By examining which wavelengths of light the comet absorbed and emitted, scientists could determine its composition with remarkable precision. They detected water ice, of course. That's the primary component of most comets. But they also found carbon monoxide, carbon dioxide, and various organic molecules. Each of these chemicals tells a story about where the comet formed and what conditions it experienced during its long journey through space. The ratios of different isotopes, variants of elements with different numbers of neutrons, provided clues about the temperature and radiation environment where the comet originated. One of the most intriguing discoveries was the high abundance of carbon monoxide relative to water. This suggested that the comet formed in an extremely cold environment, colder even than the outer reaches of our own solar system. Carbon monoxide sublimates at a much lower temperature than water ice. So a comet rich in carbon monoxide must have formed and been preserved in a place where temperatures never rose above about 250 degrees Celsius. This could mean it formed in the outer regions of another star system, or perhaps in the interstellar medium itself, in the cold darkness between stars. The detection of organic molecules was particularly exciting for astrobiologists. These carbon-based compounds are the building blocks of life as we know it, and finding them in an interstellar comet suggests that the ingredients for life might be common throughout the galaxy. The comet contained simple organics like methanol and formaldehyde, but also hints of more complex molecules that couldn't be fully identified with the available data. Each of these molecules represents a possible seed, a potential catalyst for chemical reactions that could, under the right conditions, lead to the emergence of life. As the comet approached the Sun, astronomers watched with growing anticipation. The increasing solar radiation would cause more material to sublimate from the comet's surface, creating a larger coma and potentially a spectacular tail. This would make the comet easier to study and might reveal additional components that were frozen solid when the comet was farther from the Sun. It's like watching an ancient scroll slowly unroll, revealing text that has been hidden for millennia. But then came the unexpected fragmentation. Through telescopes around the world, astronomers watched as the comet began to break apart. The Hubble Space Telescope captured particularly dramatic images, showing the comet's nucleus splitting into multiple pieces, each surrounded by its own cloud of debris. This wasn't entirely surprising. Comets are fragile objects held together by weak forces, and many comets break apart as they approach the Sun. But the timing and manner of 3I Atlas's fragmentation provided valuable scientific data. The fragmentation revealed the comet's internal structure in a way that would have been impossible if it had remained intact. As the pieces separated, fresh surfaces were exposed to sunlight for the first time in billions of years. These surfaces immediately began sublimating, releasing gases and dust that had been locked in the comet's interior since its formation. Spectroscopic analysis of these newly released materials showed subtle differences from what had been observed from the comet's original surface, suggesting that the comet had a layered structure, like a cosmic onion, with different compositions at different depths. The way the comet fragmented also told scientists about its mechanical properties. The pieces didn't explode apart violently. Instead, they gently drifted away from each other, suggesting that the comet was more like a loosely bound rubble pile than a solid chunk of ice. This has important implications for understanding how comets form and evolve. If comets are loose aggregations of smaller pieces, it suggests they formed through gentle accretion in the cold outer regions of stellar systems, rather than through more violent processes. Each fragment of the comet became a separate object of study. Some fragments were brighter than others, suggesting different compositions or different sizes. Some fragments showed jets of gas and dust shooting out in specific directions, indicating that volatile pockets within the original comet were now exposed and actively sublimating. Some fragments seemed to fragment further, creating a cascade of smaller and smaller pieces. It was like watching a single research subject multiply into dozens, each offering its own insights into the nature of the original object. The velocity measurements of the fragments were particularly interesting. As the pieces separated, each was given a slightly different speed and direction. By carefully measuring these velocities, scientists could work backward to understand the forces that caused the fragmentation. Was it thermal stress from uneven heating by the Sun? Was it the pressure of sublimating gases building up inside the comet until it burst apart? Was it the centrifugal force from the comet's rotation? The data suggested it was probably a combination of all these factors, a perfect storm of forces that overwhelmed the weak gravity holding the comet together. The chemical analysis of the fragments revealed something remarkable. Not all pieces had the same composition. Some were richer in water ice, others in carbon dioxide, still others in organic molecules. This heterogeneity suggested that the comet wasn't uniformly mixed, but had preserved different regions with different compositions from its formation. It was like finding a geological record written in ice and dust, each layer telling us a different chapter of the comet's history. One particularly intriguing observation was the detection of what appeared to be crystalline water ice in some of the fragments. This was unexpected because crystalline ice should have long ago transformed into amorphous ice during the comet's long journey through the cold of interstellar space. The presence of crystalline ice suggested that either the comet had been heated at some point in its past, perhaps during a close encounter with a star, or that some process we don't fully understand had preserved or reformed the crystalline structure. It was another piece of the puzzle that didn't quite fit with our standard models, another hint that this interstellar visitor had stories to tell that we're only beginning to decipher. The dust released by the comet was analysed using a technique called polarimetry, which measures how light is polarised as it reflects off the dust particles. This can tell scientists about the size, shape, and composition of the dust grains. The results showed that 3I Atlas's dust was unusually fine, with most particles smaller than a micrometer across. This fine dust would spread more widely through space than larger particles, potentially increasing the comet's influence on any planets it passed near. Some of this dust undoubtedly reached Earth. While we couldn't detect individual particles from the comet hitting our atmosphere, statistical models based on the comet's trajectory and dust production rate suggest that Earth passed through the outer edges of the comet's dust cloud. The particles would have been so small and entered the atmosphere at such high speeds that they would have vaporized instantly, their atoms mixing with our upper atmosphere. It's a sobering thought that right now, as you breathe, you might be inhaling atoms that once were part of Comet 3I Atlas, atoms that formed around another star and travelled through interstellar space to become part of our world. The study of the comet's orbit revealed another layer of mystery. While it was definitely on a hyperbolic trajectory, meaning it came from outside our solar system and would return to interstellar space, the exact origin was impossible to determine. The comet's path had been influenced by the gravity of every star it passed near during its journey, by the collective gravity of the galaxy itself, even by close encounters with other interstellar objects. Trying to trace its path backward was like trying to determine where a leaf floating down a river came from by watching which way it drifts. However, scientists could make some educated guesses. The comet's trajectory suggested it came from the general direction of the constellation Cassiopeia, and its velocity was consistent with the typical speeds of objects in our local stellar neighbourhood. This meant it probably didn't come from too far away, perhaps from a star system within a few dozen light-years of Earth. Some astronomers even attempted to identify specific stars that the comet might have originated from, checking to see if any nearby stars had been in the right position millions of years ago to have been the comet's birthplace. One candidate was the star system HD 7977, a sun-like star about 247 light-years away. Calculations showed that about 3 million years ago, this star would have been in approximately the right position to have ejected a comet on a trajectory that would bring it through our solar system now. But this was far from certain. The uncertainties in the measurements, combined with the chaotic nature of orbital dynamics over such long time scales, meant that we might never know for sure where 3I Atlas came from. The timing of the comet's passage through our solar system raised interesting questions about the frequency of such events. If interstellar comets pass through our solar system regularly, why have we only detected a few of them? Part of the answer is that we've only recently developed the technology to detect such objects, while they're still far from the Sun. But another part might be that most interstellar objects are much smaller or darker than 3I Atlas, making them essentially invisible to our current instruments. Statistical models based on the few interstellar objects we have detected suggest that there might be thousands of such objects passing through our solar system at any given time. Most are too small or too distant to detect, silent visitors passing through our cosmic neighborhood without our knowledge. Each one potentially carries material from another star system. Each one potentially influences the orbits of other objects through its gravity. Each one potentially delivers exotic materials to the planets and moons they pass near. The fragmentation of 3I Atlas created what astronomers call a debris stream, the elongated cloud of particles following similar but not identical orbits. This stream would spread out over time, with faster particles pulling ahead and slower ones falling behind. Earth's orbit might intersect this stream multiple times over the coming decades, each time potentially receiving a gentle dusting of interstellar material. These encounters would be too subtle to create visible meteor showers, but sensitive instruments might be able to detect unusual isotope ratios in atmospheric samples that could be traced back to the comet. The study of the comet also involved what scientists call negative observations, things they expected to see but didn't. For example, they didn't detect certain molecules that are common in comets from our own solar system. The absence of these molecules was just as informative as the presence of others, suggesting that the comet formed under different conditions than our local comets. It's like reading a book where certain words are conspicuously absent, their absence telling you something about the author's background or intentions. One particularly interesting negative observation was the lack of detectable large organic molecules. While simple organics were abundant, the complex carbon chains that some scientists hoped to find were either absent or below the detection threshold. This could mean that the comet formed in an environment where such molecules couldn't survive, perhaps due to high radiation levels or extreme temperatures. Or it could mean that these molecules were present but locked away in the comet's interior, never exposed by the fragmentation. The magnetic field measurements around the comet provided another piece of the puzzle. As the solar wind, the stream of charged particles from the sun, encountered the comet's coma, it created a complex magnetic environment that scientists could study using spacecraft data. These measurements reveal the density and composition of the comet's coma with greater precision than optical observations alone could provide. They showed that the comet was losing mass at a rate of several tons per second at its peak activity, a cosmic hemorrhaging that would have completely destroyed the comet if it had lasted much longer. The radio observations of the comet detected emissions from various molecules as they were excited by solar radiation. Each molecule emits radio waves at specific frequencies, like a cosmic barcode that identifies its presence. The strength of these emissions told scientists not just what molecules were present, but how abundant they were and how they were distributed around the comet. Some molecules were concentrated near the nucleus, while others were found throughout the extended coma, suggesting different sublimation temperatures and behaviors. One of the most sophisticated analyses involved comparing the comet to computer models of how comets should behave. Scientists have developed complex simulations that account for solar heating, rotation, sublimation, and other factors to predict how a comet should brighten and develop as it approaches the sun. Comet 3I Atlas didn't quite match these predictions, suggesting that either our models are incomplete or that interstellar comets behave differently than local ones. Each deviation from the model was a clue, a hint that there was something unique about this visitor. The infrared observations were particularly revealing because they could detect heat radiation from the comet's nucleus, even when it was obscured by dust. These measurements showed that the nucleus was smaller than initially estimated, perhaps only a few hundred meters across rather than a kilometer or more. This small size made the comet's initial brightness even more remarkable, and suggested that it was unusually active for its size, perhaps because its surface was particularly rich in volatile materials. As the comet fragments continued to spread apart, each became fainter and harder to track. Eventually they faded below the detection threshold of even our most powerful telescopes, but their disappearance from view didn't mean they ceased to exist or ceased to have influence. The fragments continue their journey through space, some heading back to the interstellar void, others perhaps captured into long-period orbits around our sun. The dust and gas released by the comet continues to spread through the solar system, becoming part of the zodiacal cloud, the diffuse disk of dust that surrounds the sun and creates the phenomenon known as zodiacal light. This zodiacal light, visible as a faint glow in the sky after sunset or before sunrise, is created by sunlight reflecting off countless dust particles orbiting the sun. Every comet that passes through the inner solar system contributes to this cloud, and now Comet 3I Atlas has added its interstellar material to the mix. When you see the zodiacal light, if you're lucky enough to be in a dark enough location, you're seeing light reflected off dust from countless comets, including, perhaps, a few particles from our interstellar visitor. The scientific instruments that study the comet represent centuries of technological development, from the basic optical telescope invented in the early 1600s to sophisticated electronic detectors that can count individual photons. Each advancement in technology has revealed new aspects of comets, new layers of complexity and beauty. The CCDs that captured images of 3I Atlas are descendants of technology developed for military satellites. The spectrographs that analyzed its composition used principles discovered by quantum physicists in the early 20th century. The computers that processed the data are the result of the digital revolution that has transformed our world over the past few decades. But perhaps the most remarkable instrument involved in studying the comet was the global network of scientists who collaborated on the observations. Astronomers from dozens of countries shared data, compared notes, debated interpretations. When the comet was below the horizon for observers in one location, colleagues on the other side of the world would take over the observations. It was a beautiful example of international cooperation, of humanity coming together to understand something larger than any one nation or culture. The data collected about Comet 3I Atlas now resides in astronomical databases around the world, available for future scientists to reanalyze with new techniques and new understanding. It's entirely possible that the most important discoveries about this comet haven't been made yet, that some future scientist, perhaps someone not even born yet, will look at this data and see something everyone else missed, some crucial clue about the nature of interstellar objects, or the formation of planetary systems, or the distribution of organic molecules in the galaxy. This is one of the beautiful aspects of science. It's cumulative, each generation building on the work of those who came before. The observations of Comet 3I Atlas join the observations of thousands of other comets in our collective scientific heritage, each one adding another piece to the vast puzzle of understanding our universe. And unlike the comet itself, which has faded from view, this data is permanent, preserved for as long as human civilization endures. The techniques developed to study 3I Atlas are already being applied to other objects. The rapid response of the global astronomical community, the coordination of observations, the quick analysis and sharing of data, these have become a model for how to study transient astronomical events. When the next interstellar visitor is detected, and there will surely be more, we'll be better prepared to study it thanks to what we learned from 3I Atlas. Some scientists have proposed dedicated missions to study interstellar objects, spacecraft that would wait in Earth orbit or at a Lagrange point, ready to be dispatched when an interesting object is detected. These missions could potentially rendezvous with an interstellar visitor, studying it up close, perhaps even collecting samples to return to Earth. Imagine holding in your hand a piece of material from another star system, being able to analyze it in terrestrial laboratories with instruments too large and complex to send to space. The scientific value would be immeasurable. The study of 3I Atlas has also influenced how we think about our own solar system's comets. If interstellar comets can visit us, then comets from our solar system must occasionally be ejected to become interstellar travelers themselves. Right now, somewhere in the galaxy, there might be comets that formed in our solar system passing through other star systems, potentially delivering Earth material to other worlds. We're not just receivers of cosmic material, we're also contributors to the galactic exchange. This raises profound questions about the spread of life through the galaxy. If comets can carry organic molecules between star systems, and if these molecules can seed the development of life, then life might not arise independently on each world, but might spread through the galaxy like seeds on the wind. Earth might have been seeded by material from elsewhere, and we in turn might be seeding other worlds. It's a humbling and inspiring thought that makes us part of a potentially galaxy-wide ecosystem. The detection capabilities that allowed us to discover 3i Atlas continue to improve. New surveys are coming online with even more powerful telescopes and more sophisticated detection algorithms. The Vera Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, will scan the entire visible sky every few nights, detecting objects far fainter than current surveys can see. It's estimated that this observatory alone might detect several interstellar objects each year, giving us a much better understanding of how common these cosmic visitors really are. Machine learning algorithms are being trained to identify unusual objects in astronomical data, to spot the subtle signatures that distinguish interstellar visitors from local comets and asteroids. These artificial intelligence systems can process vast amounts of data far faster than human astronomers, potentially catching fleeting events that would otherwise be missed. It's a partnership between human creativity and machine processing power that promises to revolutionize our understanding of the cosmos. The radio silence from Comet 3i Atlas was itself informative. Some scientists had hoped to detect radio emissions that might indicate the presence of certain molecules, or even, in the wildest speculation, signs of artificial origin. While no such signals were detected, the non-detection helped constrain what the comet could and couldn't be. It was almost certainly a natural object, a chunk of ice and rock formed through normal astrophysical processes rather than something more exotic. The polarization of light reflected from the comet told scientists about the shape and alignment of dust particles in its coma. These measurements showed that the particles were predominantly irregular in shape rather than spherical, and that they showed no preferred alignment. This randomness suggested that the particles were released gently rather than explosively, consistent with sublimation rather than a more violent fragmentation process. The color of the comet, or more precisely its spectrum across different wavelengths, revealed that it was slightly redder than typical solar system comets. This reddening could be due to the presence of complex organic molecules on the comet's surface, molecules that had been processed by billions of years of exposure to cosmic rays. Or it could indicate a different mineral composition, perhaps with more iron-bearing minerals than typical comets. The exact cause of the reddening remains a subject of scientific debate. Temperature measurements of the comet's surface derived from infrared observations showed that it was absorbing solar radiation very efficiently, heating up more than expected for an object of its size and distance from the sun. This high absorption suggested that the surface was very dark, perhaps covered with a layer of organic material or fine dust that trapped sunlight. This dark surface might have contributed to the comet's fragmentation by creating temperature gradients that stressed the internal structure. The study of how the comet's brightness changed over time, what astronomers call its light curve, revealed periodic variations that suggested the nucleus was rotating. The period of rotation was estimated to be about 8 hours, fairly typical for a comet of its size. But the amplitude of the variations was larger than expected, suggesting that the nucleus was highly elongated or had an irregular shape. This irregular shape might have contributed to the fragmentation by creating uneven heating and stress points. Spectroscopic observations in the ultraviolet range, conducted by space-based telescopes above Earth's atmosphere, detected emissions from hydrogen and oxygen atoms. These atoms were produced when water molecules from the comet were broken apart by solar ultraviolet radiation, a process called photodissociation. The rate of this process told scientists how much water the comet was losing and how this rate changed as it approached the sun. The detection of carbon-bearing molecules in the comet's spectrum was particularly exciting for astrobiologists. These molecules, including things like cyanogen, CN, and diatomic carbon, C2, are precursors to more complex organic molecules. Their presence in an interstellar comet suggests that the building blocks of life might be common throughout the galaxy, constantly being shuffled between star systems by comets like 3I Atlas. Some of the most precise measurements came from stellar occultations, brief moments when the comet passed in front of background stars. By carefully timing when the star's light was blocked and when it reappeared, astronomers could measure the size and shape of the comet's nucleus and coma with extraordinary precision. These measurements revealed fine structure in the coma, jets and streamers of material that weren't visible in direct images. The isotope ratios measured in the comet's spectrum provided clues about its formation environment. The ratio of different isotopes of hydrogen, carbon, nitrogen, and oxygen can tell scientists about the temperature and radiation environment where the comet formed. The ratios in 3I Atlas were subtly different from those in solar system comets, confirming its interstellar origin and providing hints about conditions in its parent star system. Ground-based radar observations attempted to bounce radio waves off the comet to directly measure its size and shape, but the comet proved to be too small and too distant for this technique to work effectively. However, the attempt itself provided valuable experience for future observations of interstellar objects, helping scientists refine their techniques and understand the limitations of current technology. The study of the comet's dust tail versus its ion tail revealed different aspects of its composition and behavior. The dust tail, made of small solid particles, was pushed away from the sun by radiation pressure. The ion tail, made of charged particles, was shaped by the solar wind and magnetic fields. The relative brightness and structure of these two tails told scientists about the ratio of dust to gas in the comet and how this ratio changed over time. Amateur astronomers around the world contributed valuable observations, tracking the comet night after night, documenting its changing appearance. Some of these observations filled crucial gaps when professional telescopes were unavailable or when weather prevented observations from major observatories. It was a beautiful example of citizen science, of people from all walks of life contributing to our understanding of the cosmos. The economic value of the scientific data collected about 3I Atlas is difficult to quantify, but surely substantial. The telescope time alone represents millions of dollars of resources. The human effort, the graduate students analyzing data, the professors interpreting results, the engineers maintaining instruments, represents countless hours of skilled labor. All of this investment for an object that appeared briefly and then vanished, leaving only data and memories. But this investment in pure science, in understanding something with no immediate practical application, is what distinguishes us as a species. We study comets not because they'll make us wealthy or powerful, but because we're curious, because we want to understand our place in the universe, because knowledge itself has value. The data from 3I Atlas adds to the vast treasury of human knowledge available for future generations to build upon. As the fragments of the comet continue their journey, they carry with them the echoes of our observation. In a quantum mechanical sense, our measurement of the comet changed it, collapsed its wave function from possibility to actuality. We became entangled with this interstellar visitor, our futures now subtly connected through the act of observation. It's a poetic thought that brings together the hardest of sciences with the softest of philosophy. The legacy of Comet 3 Atlas in scientific literature continues to grow. Papers are still being published analyzing different aspects of the data, proposing new interpretations, comparing it to other comets. Each paper adds another layer of understanding, another perspective on what this cosmic visitor meant. The comet has become part of the scientific conversation, a reference point for future studies, a calibration mark for our understanding of interstellar objects. Graduate students are earning their degrees studying data from the comet, launching careers that will span decades. Some of these students will become the senior scientists who study the next generation of interstellar visitors, bringing with them the experience and insights gained from 3I Atlas. In this way, The comet's influence extends not just through space, but through time, shaping the future of astronomical research. The technological innovations spurred by the desire to better study objects like 3i Atlas will have applications beyond astronomy. Better detectors, faster computers, more sophisticated algorithms. These tools developed for astronomy often find uses in medicine, communications, environmental monitoring, and other fields. The quest to understand a comet from another star system might lead to technologies that improve life here on Earth in ways we can't yet imagine. As we contemplate the vast amount of data collected about this single comet, it's worth remembering that it represents just one object among countless trillions in our galaxy alone. Each star might have its own collection of comets, its own Oort cloud sending ambassadors out into the galaxy. The amount of material being exchanged between star systems, the complexity of the interactions, the richness of the chemistry, it's beyond human comprehension in its totality. We can only sample tiny portions, glimpse fragments of the whole, like trying to understand an ocean by studying a single drop of water. Yet from that single drop we can learn so much. The presence of certain molecules tells us about temperature. The isotope ratios tell us about stellar nucleosynthesis. The orbital dynamics tell us about gravity and the structure of our galaxy. Each observation is a thread that connects to every other observation, weaving together into a tapestry of understanding that grows richer with each new contribution. The instruments that study 3 Atlas are already being improved, upgraded, replaced with even more capable successors. The next interstellar visitor will be studied with tools we don't have yet, will reveal aspects of the cosmos we can't currently observe. The science of the unseen is constantly expanding, pushing back the boundaries of ignorance, revealing new mysteries even as it solves old ones. In the grand narrative of cosmic exploration, Comet 3 Atlas was a brief chapter, a few months of observation in the billions of years of cosmic history. But it was our chapter, humanity's encounter with this particular messenger from the stars. We rose to meet it with our best technology, our most careful observations, our deepest curiosity. And in doing so, we demonstrated that we're ready for whatever other cosmic surprises await us. The echoes in the ice continue to reverberate, each molecule from the comet that found its way to Earth becoming part of our world's story. In the polar ice caps, in the deep ocean, in the upper atmosphere, atoms that travel between the stars are now part of Earth's inventory. They're indistinguishable from local atoms, having lost their cosmic identity to become part of our world. Yet they carry with them the history of their journey, encoded in their isotopic signatures, waiting for future scientists with even more sensitive instruments to decode their stories. We stand at a unique moment in the history of our planet, perhaps in the history of the universe. We're conscious beings capable of detecting and studying objects from other star systems, of understanding our cosmic context, of appreciating the vast scales of space and time in which we exist. Comet 3i Atlas arrived at just the right time to be part of this moment, to contribute to our growing understanding of our place in the cosmos. It's a reminder that we're living in an age of discovery, an age when the invisible becomes visible, when the unknown becomes known, when visitors from other stars become part of our story. The ice that formed around another star billions of years ago has now melted in our solar system, its molecules mixing with our worlds. The dust that accumulated in an alien stellar nursery now drifts through our skies. The organic molecules that might have been the precursors to alien life are now part of Earth's chemical inventory. We're richer for this cosmic gift, even if we can't measure exactly how much richer. The universe has shared some of its secrets with us, delivered by a fragile messenger that broke apart even as we watched, ensuring that its gifts would be spread as widely as possible. As you continue to drift towards sleep, carried on these waves of cosmic contemplation, remember that you're made of similar stuff as that comet. The water in your body, the carbon in your cells, the calcium in your bones, all of it came from space. All of it has been on incredible journeys you can barely imagine. You're not separate from the cosmic story. You're a chapter in it, written in atoms and molecules that have travelled the universe. And just as Comet 3i Atlas brought its material to our world, you bring your own unique arrangement of cosmic material to each moment, each breath, each thought. The philosophy of a near miss invites us to consider what it means when something passes close to us without directly impacting our lives, yet leaves us changed simply by its presence, by our awareness of it. Comet 3 Atlas never came particularly close to Earth in astronomical terms. It stayed well outside our orbit, never posing any danger to our world. Yet its passage was a near miss in a deeper sense, a brush with the cosmic unknown that reminded us of our place in a universe far larger and more mysterious than our everyday experience suggests. There's something profound about objects that pass near us without touching, that influence us through their mere presence rather than through direct contact. Think about how many times in your life you've been affected by near misses, the accident that almost happened, the opportunity that almost materialized the person you almost met. These non-events can be as influential as actual events, shaping our thoughts, our emotions, our future choices. They remind us that reality is just one path through an infinite forest of possibilities, and that other paths passed close enough for us to glimpse them, to wonder what might have been. In cosmic terms, near misses are constant. Every second, countless cosmic rays pass through your body without interacting with any of your atoms. Neutrinos from the sun, from distant supernovae. From the Big Bang itself stream through Earth as if it weren't there. Dark matter, if it exists as most physicists believe, is passing through you right now, exerting its gravitational influence but otherwise remaining completely undetectable. We live in a universe of near misses, of influences that barely touch us yet shape the fabric of reality around us. The trajectory of Comet 3 Atlas brought it within about 0.6 astronomical units of Earth at its closest approach. That's about 90 million kilometers, more than half the distance from Earth to the Sun. In our everyday experience, that's an unimaginable distance. You could line up more than 7,000 Earths between us and the comet at its closest point. Yet in cosmic terms, this was indeed a close encounter. The comet passed through our solar system's habitable zone, the region where liquid water can exist on planetary surfaces, the narrow band where life as we know it can thrive. Consider what this means philosophically. An object from another star system, carrying material that formed under alien suns, passed through the zone where life exists in our solar system. It's as if the universe briefly brought two separate experiments in stellar and planetary formation close enough to compare notes, to exchange materials to influence each other's futures. The comet didn't need to hit Earth to affect us. Its mere passage through our neighborhood was enough to alter the distribution of material in our solar system, to change the gravitational landscape, to inspire human thoughts and actions that wouldn't have occurred otherwise. The concept of action at a distance has puzzled philosophers and physicists for centuries. How can one object influence another without touching it? Newton's gravity seemed to act instantaneously across vast distances, a mystery that troubled even Newton himself. Einstein resolved this by showing that gravity is the curvature of space-time, that massive objects create valleys in the fabric of reality that other objects roll into. But this just pushes the mystery back a level. How does an object curve space-time around itself? How does the universe know to bend in response to mass? Comet 3i Atlas, small as it was compared to planets, still curved space-time around itself. Every atom in the solar system felt its gravitational influence, however minutely. The comet pulled on Earth, just as Earth pulled on the comet, an exchange of influence across millions of kilometers of apparent emptiness. But that emptiness isn't really empty. It's filled with fields, with virtual particles popping in and out of existence, with the quantum foam that underlies reality. The comet's passage disturbed these fields, sent ripples through the quantum vacuum, left traces in dimensions we can't directly perceive. In quantum field theory, every particle is an excitation in an underlying field that extends throughout the universe. An electron isn't a tiny ball of charge, it's a ripple in the electron field. A photon is a ripple in the electromagnetic field. And perhaps, though this is still speculative, gravitons are ripples in the gravitational field. When Comet 3I Atlas passed through our solar system, it created ripples in all these fields, disturbances that propagated outward at the speed of light, eventually reaching every corner of the observable universe. These field disturbances are usually too small to measure, but they're not nothing. They represent real changes in the fabric of reality, alterations in the probability distributions that govern quantum events. A particle that might have decayed at one moment might now decay at a slightly different moment. A quantum tunneling event that might have occurred might now not occur, or vice versa. These are tiny changes, but in a universe governed by chaos theory, tiny changes can have large consequences over time. The philosophical implications of quantum entanglement add another layer to our contemplation. When particles interact, they can become entangled. Their quantum states correlated in ways that persist, even when the particles are separated by vast distances. Did any particles from Comet 3I Atlas become entangled with particles in our solar system? If so, there are now particles on Earth whose quantum states are correlated with particles heading back to interstellar space. A connection that transcends classical physics, a bridge between our world and the cosmic void. This entanglement, if it exists, would mean that measurements performed on Earth could instantaneously affect the quantum state of particles from the comet now millions of kilometers away. Not in a way that could transmit information that would violate relativity, but in a way that demonstrates the non-local nature of quantum reality. The comet hasn't just left and gone. In a quantum sense, part of it remains connected to us. Part of us is connected to it, bound together in the mysterious dance of entangled states. The many worlds interpretation of quantum mechanics, which we touched on earlier, suggests that every quantum event causes reality to branch into multiple parallel universes. If this is true, then the passage of Comet 3I Atlas created countless new universes, each slightly different from the others. In some of these universes, the comet fragmented differently. In others, it didn't fragment at all. In some, its gravitational influence caused an asteroid to change course. In others, different quantum events occurred in the atoms of observers watching the comet, leading to different thoughts, different insights, different futures. We can only experience one of these branches, one path through the infinite garden of forking paths. But the existence of other branches, if real, means that every possibility is explored somewhere in the multiverse. There are versions of reality where Comet 3 Atlas had profound effects on Earth's future, and versions where it had no effect at all. We can't know which branch we're on until the future unfolds, until the consequences of the comet's passage, if any, become apparent. The anthropic principle, which we mentioned before, takes on new dimensions when considered in the context of near misses. Why do we observe a universe where comets occasionally pass close to Earth but rarely hit it? One answer is that in universes where large comets frequently impact Earth, complex life doesn't evolve to ask the question. We observe a universe of near misses because that's the kind of universe that allows observers to exist. The rarity of catastrophic impacts and the frequency of close passes might be fine-tuned by the simple fact that we're here to observe them. But perhaps there's more to it than survival bias. Perhaps near misses serve an evolutionary purpose, providing just enough disruption to drive evolution without causing extinction. The gravitational influence of passing comets might trigger minor climate changes that create new ecological niches. The delivery of exotic materials might provide new chemical possibilities for life to explore. The psychological impact on conscious beings might spur technological and cultural development. Near misses might be the universe's way of nudging life forward without destroying it. The concept of synchronicity, introduced by psychologist Carl Jung, suggests that events can be meaningfully related without being causally connected. The appearance of Comet 3I Atlas in late 2019 just before the world would be transformed by a pandemic, might be seen as a synchronistic event. Not that one caused the other, but that both were expressions of some deeper pattern, some underlying rhythm in the universe that brings changes in clusters. Throughout history, comets have appeared at moments of transformation. The Great Comet of 1680 appeared during the Scientific Revolution. Halley's Comet returned in 1910, just as the world was about to be transformed by World War I and the technological revolutions of the 20th century. The appearance of Hale-Bopp in 1997 coincided with the dawn of the Internet age. Are these correlations meaningful or mere coincidence? Science can't answer that question, but philosophy invites us to wonder. The Buddhist concept of pratyatyasamutpada, or dependent origination, teaches that all phenomena arise in dependence upon multiple conditions and cease when those conditions are no longer present. Nothing exists in isolation. Everything is interconnected in a web of relationships. Comet 3I Atlas arose from conditions in another star system, travelled through space due to gravitational influences, appeared in our sky because we developed the technology to see it, and fragmented due to solar heating. Its existence was contingent on countless factors, and its influence spreads through countless more. From this perspective, asking whether the comet altered Earth's timeline is like asking whether a single thread alters a tapestry. The thread is part of the tapestry. Without it, the tapestry would be different, even if the difference is subtle. Every cosmic event, every passing comet, every particle of interstellar dust is a thread in the tapestry of reality. Remove any one, and the whole pattern changes. The Stoic philosophers would have seen the passage of Comet 3 Atlas as an opportunity to practice amor fati, love of fate. The comet came because it had to come, following the laws of physics that govern the universe. Its fragmentation was not a disappointment, but a revelation of its nature. Our observation of it was not accidental, but part of the cosmic order. Everything happened exactly as it had to happen, and our task is not to wish it were different, but to understand and accept it as part of the cosmic harmony. Yet acceptance doesn't mean passivity. The Stoics also believed in responding appropriately to events, in playing our role in the cosmic drama. Scientists studying the comet, sharing data, publishing papers, these are appropriate responses to a cosmic event. Each person who looked up at the night sky hoping to see the comet, each child who learned about it in school, each dreamer who wondered about its origins, all were participating in humanity's response to this cosmic visitor. The existentialist philosophers would emphasize that the comet's meaning isn't inherent in the comet itself, but is created by our encounter with it. Comet 3I Atlas was just a chunk of ice and rock until we observed it, named it, studied it, wondered about it. We transformed it from a meaningless object into a meaningful event through our engagement with it. Its significance lies not in its physical properties, but in what it represents to us, our cosmic loneliness and connection, our technological achievement and natural limitations, our brief moment of consciousness in a vast unconscious universe. Heidegger's concept of thrownness, Geworfenheit, resonates with the comet's journey. Just as humans are thrown into existence without choosing it, the comet was thrown into its interstellar journey by forces beyond its control. It didn't choose to visit our solar system any more than we chose to be here when it arrived. Yet here we both are, thrown together by the cosmic forces that shape reality, making the best of our brief encounter. The phenomenologist would point out that our experience of the comet is always mediated by our consciousness, our instruments, our theories. We never experience the comet itself, only our perceptions and measurements of it. The photons that reached our telescopes were not the comet, but radiation that had interacted with the comet. The spectra we analysed were not the comet's essence, but the fingerprints it left in light. Even our most direct observations are interpretations, constructions of meaning from sensory and instrumental data. This raises profound questions about the nature of scientific knowledge. Can we ever truly know an object like Comet 3 Atlas? Or do we only know our representations of it? Is there a comet in itself beyond our observations, or is the comet constituted by our observations? These questions matter because they affect how we think about the comet's influence. If the comet exists independently of our observation, its effects on Earth's timeline are objective facts. If the comet is partially constituted by our observation, then we're not just passive observers, but active participants in creating the reality we study. The process philosophers, following Alfred North Whitehead, would see Comet 3I Atlas not as a thing but as a process, a series of events unfolding through time. The comet wasn't a static object that moved through space, but a dynamic process of becoming and perishing. Each moment, parts of the comet sublimated into gas, new surfaces were exposed, gravitational influences accumulated. The comet we detected in December 2019 wasn't the same comet that fragmented months later, just as you're not the same person who began listening to this story. This processual view has implications for how we think about the comet's influence on Earth's timeline. The influence isn't a one-time event, but an ongoing process. Particles from the comet continue to rain down on Earth. Gravitational perturbations continue to propagate through the solar system. The scientific knowledge gained from studying the comet continues to influence human thought and action. The comet's influence is not past but present, not finished but continuing. The pragmatist philosophers would ask, what practical difference does it make whether Comet 3I Atlas altered Earth's timeline? If we can't detect the alteration, if it doesn't affect our lives in any measurable way, does the question have any meaning? William James would argue that the question matters only if believing one answer or another has consequences for how we live. If believing that the comet altered our timeline makes us more aware of cosmic influences, more humble about our place in the universe, more curious about the cosmos, then the belief has value regardless of whether it's literally true. Perhaps the most profound philosophical implication of the comet's near miss is what it reveals about contingency and necessity. The comet's trajectory was necessary given the laws of physics and its initial conditions, yet it was contingent on those initial conditions which themselves were contingent on earlier conditions, and so on back to the Big Bang or beyond. Our observation of the comet was necessary given our technology and curiosity, yet contingent on the entire history of human evolution and cultural development. This interplay of necessity and contingency means that the comet's passage was both inevitable and impossibly unlikely. Given the initial conditions of the universe, it had to happen exactly as it did. Yet those initial conditions could have been slightly different, leading to a universe where this particular comet never formed, or formed but never visited our solar system, or visited but wasn't observed. We live in the one universe where all the contingencies aligned for this particular encounter to occur. The philosophical concept of kairos, which we mentioned earlier, takes on special significance here. Kairos is not just any time but the right time. The opportune moment, the time when something special can happen. The passage of Comet through our atlas might have been such a kairos moment for humanity, not in the sense that it directly changed our future, but in the sense that it arrived at just the moment when we were ready to appreciate its significance, to use it as a mirror for reflecting on our cosmic situation. Consider the timing. The comet appeared just as humanity was reaching new levels of global interconnection through technology, just as we were beginning to seriously contemplate becoming a multiplanetary species, just as we were discovering thousands of exoplanets and wondering about life elsewhere in the universe. It arrived at a moment when we could not only detect it but understand its significance as a visitor from another star system. A century earlier, we might have seen it, but not understood what it was. A century later, such visits might be routine. But right now, at this moment in human history, it was special. The comet also appeared at a time when humanity was grappling with global challenges that require us to think beyond national boundaries, to see Earth as a single system, to understand our interconnectedness. The comet didn't recognize human borders. Its influence, whatever it might be, affects the entire planet equally. It's a reminder that we share a common cosmic heritage, that we're all riders on the same small world, subject to the same cosmic influences. From a philosophical perspective, near misses like Comet 3I Atlas serve as reminders of our cosmic vulnerability and resilience. We're vulnerable because we're subject to cosmic forces beyond our control. Comets, asteroids, solar flares, supernovae, gamma-ray bursts. Any of these could end human civilization or even all life on Earth. Yet we're resilient because we've survived billions of years of cosmic bombardment, evolved consciousness and intelligence, developed technology that can detect and potentially deflect cosmic threats. The comet's fragmentation adds another philosophical dimension. The comet couldn't withstand its encounter with our Sun. It broke apart under stresses that Earth experiences every day. This fragility reminds us that not everything that ventures close to us survives the encounter. We live in a region of space that's hostile to fragile objects, where solar radiation and gravity create forces that can tear visitors apart. Yet we've evolved to thrive in this environment, to call it home. This raises questions about what kinds of cosmic influences can affect us. If we're adapted to our local environment, might we be particularly sensitive to influences from outside that environment? Could materials or forces that are common in interstellar space, but rare in our solar system, have disproportionate effects on Earth? The exotic materials delivered by Comet 3I Atlas, even in tiny quantities, represent influences our biosphere hasn't evolved defenses against. The philosophy of emergence suggests that complex systems can exhibit properties that aren't present in their individual components. Life emerges from chemistry, consciousness from neurology, culture from individual minds. Could the influence of Comet 3I Atlas trigger emergent properties in Earth's biosphere or human civilization? Could the combination of exotic materials, gravitational perturbations, and human awareness of the comet create something genuinely new, something that couldn't have existed without all these factors coming together? We might not recognize such emergent properties immediately. Emergence often requires time to manifest, for interactions to compound, for patterns to self-organize. The influence of the comet might be like a seed that takes years or decades to germinate, or a catalyst that only works in combination with other factors that haven't yet appeared. We might be in the early stages of an emergent process triggered by the comet, unable to see the pattern because we're too close to it in time. The philosophical tradition of phenomenology reminds us that our experience of the comet is always embodied, always from a particular perspective. We observe the comet from Earth, through Earth's atmosphere, using instruments designed by Earth-evolved beings. Our understanding of the comet is inevitably Earth-centric, shaped by our particular position in space and time. An observer from another star system, or from another time in Earth's history, would have a completely different experience and understanding of the same object. This perspectival nature of knowledge means that our assessment of whether the comet altered Earth's timeline is necessarily limited and partial. We can't step outside our timeline to compare it with an alternative timeline where the comet didn't visit. We can't see all the comet's influences because some might be too small, too slow, or too complex for us to detect. We're like characters in a story trying to understand how a particular chapter affects the plot. We won't know until we reach the end, and maybe not even then. The ancient Greek philosopher Heraclitus said that you can't step into the same river twice, because the river is constantly changing. The same is true of Earth's timeline. It's not a fixed track, but a flowing river, constantly changing, influenced by countless factors. Comet 3I Atlas was one drop in this river, perhaps insignificant by itself, but contributing to the overall flow. The question isn't whether it altered the timeline, but how it participated in the timeline's constant alteration. The Taoist concept of Wu Wei, often translated as non-action or effortless action, provides another lens through which to view the comet's influence. The comet didn't try to influence Earth, it simply followed its nature, moving along its trajectory, sublimating in the sun's heat, fragmenting when the stresses became too great. Yet through this non-action, through simply being what it was, it potentially influenced everything in our solar system. This is Wu Wei, achieving effect without forcing, influencing without intending. We might learn from the comet's example. Perhaps the most profound influences are not the ones we deliberately create, but the ones that arise naturally from us being what we are. By studying the comet, by wondering about it, by sharing our wonder with others, we're influencing Earth's timeline in ways we can't predict or control. Our curiosity about the cosmos might be as significant as any physical influence the comet had. The philosophical concept of sublime, as developed by Kant and others, captures something essential about our encounter with Comet 3 Atlas. The sublime is the feeling we experience when confronted with something vast, powerful, or mysterious that overwhelms our ability to comprehend it fully. The comet, coming from unimaginable distances, carrying incomprehensible age, breaking apart in a display of cosmic forces, evokes this sense of sublime, a mixture of awe, wonder, and humility. This experience of the sublime might be the comet's greatest gift to us. In our everyday lives, it's easy to forget the vast scales of space and time in which we exist. The comet reminded us that we're part of something immeasurably larger than ourselves, something beautiful and terrible and mysterious. This reminder might influence human consciousness in subtle but important ways, inspiring art, philosophy, scientific research, or simply a greater appreciation for the cosmos. As we continue our contemplation, drifting deeper into the philosophical implications of this cosmic near-miss, we find ourselves at the intersection of science and meaning, fact and interpretation, observation and imagination. The comet was both a physical object following the laws of physics and a symbolic event rich with meaning. It was both a collection of ice and dust and a messenger from the stars. It was both a near miss in terms of physical distance and a direct hit in terms of psychological and philosophical impact. The question of whether Comet 3I Atlas altered Earth's future timeline thus becomes not just a scientific question, but a philosophical one. It challenges us to think about the nature of influence, the meaning of change, the relationship between physical events and their significance. It invites us to consider ourselves not just as observers of the cosmos, but as participants in it, influenced by and influencing the vast web of relationships that connects all things. Perhaps the comet's passage was like a stone thrown into a still pond. The stone itself quickly sinks from view, but the ripples it creates spread outward, interacting with other ripples, reflecting off the shores, creating patterns of interference and reinforcement. We can't track every ripple, can't predict how they'll all interact, but we know the pond has been changed, however subtly. The pattern of waves is different than it would have been, and that difference, however small, is real. In the end, the philosophy of a near miss teaches us about possibility and actuality, about the paths taken and not taken, about the fine line between significance and insignificance. Comet 3I Atlas passed close enough to matter, but not close enough to dominate. It influenced us enough to notice, but not enough to be certain of its effects. It exists in that liminal space between presence and absence, between something and nothing, between changing everything and changing nothing. This liminal space is where philosophy thrives, where questions are more important than answers, where wonder is more valuable than certainty. The comet gave us a gift of uncertainty, a mystery to ponder, a reason to look up at the night sky and wonder what other influences are streaming toward us from the depths of space and time. It reminded us that we're not isolated on Earth, but connected to the cosmos in ways we're only beginning to understand. As you continue to relax, to let these thoughts wash over you like gentle cosmic waves, consider that every moment is a near miss with infinity. Every second, countless possibilities pass close to us without manifesting. Every choice we make, Every thought we think, every breath we take is a near miss with all the other choices, thoughts, and breaths we might have made. We're constantly brushing against alternative timelines, alternative selves, alternative futures, most of which we'll never know. Comet 3I Atlas was one particularly visible near miss, one we could observe and measure and contemplate. But it represents countless invisible near misses happening all around us all the time. Every cosmic ray that almost interacts with our DNA, every quantum event that almost triggers a cascade of changes, every idea that almost forms in someone's mind, these are all near misses that shape our reality through their absence as much as their presence. The search for ripples from this cosmic encounter is not just a scientific endeavor, but a philosophical and spiritual one. We're searching not just for physical effects, but for meaning, not just for data, but for understanding, not just for answers, but for better questions. The ripples we're looking for might be in the realm of consciousness rather than physics, in the domain of possibility rather than actuality, in the space between what is and what might be. As we prepare to drift even deeper into contemplation, to explore how we might search for and recognize the comet's influence, remember that the search itself is part of the influence. By looking for ripples, we create ripples. By wondering about changes, we become changed. By contemplating cosmic influences, we become more cosmic in our perspective. The comet has already altered Earth's timeline simply by inspiring us to ask whether it has altered Earth's timeline. The search for ripples from Comet 3 Atlas takes us into a realm where science becomes almost like archaeology, where we're looking for traces so faint they might be indistinguishable from the background noise of cosmic activity that constantly surrounds us. Yet this search is perhaps one of the most profound endeavors we can undertake, for in looking for the comet's influence, we're really exploring the fundamental question of how connected we are to the cosmos, how sensitive our world is to gentle touches from beyond, how the future might be shaped by influences so subtle we can barely detect them. Imagine for a moment that you're a detective, but not investigating a crime that happened in the past. Instead, you're investigating a possibility that might manifest in the future, tracking clues that are still forming, following ripples that haven't yet reached their destinations. This is the nature of searching for the comet's influence on our timeline. We're not looking for something that has definitively happened, but for something that might be happening, slowly, quietly, perhaps taking centuries or millennia to fully express itself. The first place we might look for ripples is in Earth's atmosphere, that thin envelope of gases that separates us from the vacuum of space and serves as our first point of contact with cosmic visitors. Every particle from Comet 3I Atlas that entered our atmosphere would have vaporized in a flash of heat and light, its atoms mixing with the air we breathe. These atoms are now part of Earth's atmospheric inventory, indistinguishable from native atoms except for possibly subtle differences in isotope ratios that might mark them as having an interstellar origin. Scientists have established monitoring stations around the world that continuously sample the atmosphere, looking for unusual isotope ratios, exotic molecules, or chemical signatures that might indicate the presence of extraterrestrial material. These stations were originally designed to monitor nuclear weapons testing, volcanic eruptions, and industrial pollution, but they've proven valuable for detecting cosmic influences as well. The data they collect creates a baseline, a record of what's normal, against which future anomalies can be measured. The challenge is that Earth receives about 40,000 tons of cosmic material every year from various sources: micrometeorites, cosmic dust, the occasional larger meteorite. Distinguishing material from Comet 3I Atlas from this background influx is like trying to identify a particular grain of sand on a beach. It requires not just detecting unusual material, but correlating its arrival time with the comet's passage, matching its composition to what we observed in the comet's spectrum, and ruling out other possible sources. One approach is to look for isotope ratios that are distinctly different from solar system norms. Every star system has its own isotopic signature based on the stellar nucleosynthesis processes that created its heavy elements. If Comet 3I Atlas truly came from another star system, its material should have isotope ratios that don't match anything formed in our solar system. These differences might be tiny, perhaps a slight excess of nitrogen-15 relative to nitrogen-14, or an unusual ratio of oxygen isotopes. But modern mass spectrometers can detect such subtle variations. The polar ice caps serve as natural archives of atmospheric composition, with each year's snowfall trapping air bubbles and particles that provide a record of what was in the atmosphere at that time. Scientists drilling ice cores from Antarctica and Greenland can extract samples from the exact time period when Comet 3I Atlas passed through our solar system. By analysing these samples with extreme precision, they might detect a spike in exotic materials or unusual isotopes that correlates with the comet's passage. But ice cores tell us more than just chemical composition. They also record volcanic eruptions, forest fires, industrial pollution, and even ancient plagues through the biological material they preserve. If the comet delivered organic molecules or even microorganisms to Earth, evidence might be preserved in these frozen archives. The search would be painstaking, requiring analysis of countless samples with techniques sensitive enough to detect single molecules. But the potential payoff, proof of interstellar material delivery to Earth, would be revolutionary. Ocean sediments provide another archive where comet material might accumulate. Particles that settle through the atmosphere eventually reach the ocean, where they slowly sink to the seafloor and become part of the sedimentary record. The constant rain of cosmic dust creates thin layers of extraterrestrial material in ocean sediments, and a particularly large influx from Comet 3I Atlas might create a detectable spike in these layers. Marine geologists using deep-sea drilling equipment could extract sediment cores from areas where computer models predict the comet's dust would have concentrated. The biological realm offers perhaps the most intriguing possibilities for detecting the comet's influence. If the comet delivered organic molecules that Earth's biosphere had never encountered before, these molecules might trigger new biochemical reactions, new evolutionary pressures, new possibilities for life. We might look for sudden changes in microbial communities, unusual mutations in organisms known to be sensitive to environmental changes, or the emergence of novel biochemical pathways that utilize molecules not previously available on Earth. Consider the possibility that somewhere in Earth's vast microbial ecosystem, bacteria or archaea have already incorporated molecules from Comet 3I Atlas into their metabolism. These organisms might be using exotic amino acids to build proteins with properties unlike anything that evolved on Earth. They might be utilizing unusual catalysts that allow chemical reactions to proceed at different rates or temperatures. They might even be experimenting with alternative genetic codes, using the comet's organic molecules as building blocks for entirely new forms of information storage and transmission. The search for such biological innovations would require extensive sampling of environments where cosmic material might concentrate, high-altitude lakes where atmospheric particles settle, caves where unusual chemistry might be preserved, deep-sea vents where extreme conditions might favor novel biochemistry. Each sample would need to be analyzed not just for known life forms, but for evidence of unusual chemistry, unexpected metabolic pathways, or genetic sequences that don't fit the standard pattern of Earth life. The human genome itself might bear traces of the comet's influence, though these would be incredibly subtle and difficult to detect. Cosmic rays and radioactive particles from space occasionally cause mutations in DNA, and if the comet delivered radioactive isotopes or increased the flux of cosmic rays through some mechanism, it might have slightly increased the mutation rate in organisms around the world. Over time, these additional mutations could lead to new genetic variations, some of which might be beneficial and become fixed in populations through natural selection. Epidemiologists might look for statistical anomalies in disease patterns or genetic disorders that correlate with the comet's passage. While it would be impossible to prove causation, Unusual clusters of mutations or the emergence of new genetic variants shortly after the comet's visit might suggest an influence. This would require analysing vast databases of genetic information, looking for patterns that might be lost in the noise of normal genetic variation. The technological sphere offers another domain where we might search for the comet's influence, though here we're looking at indirect effects mediated through human consciousness and culture. Did the observation of Comet 3I Atlas inspire any technological innovations? Did it influence funding decisions for space exploration? Did it change how we think about planetary defense or the search for extraterrestrial life? These influences would be even harder to quantify than physical effects, but they might ultimately be more significant for humanity's future. We might examine patent filings, scientific publications, and research grant proposals from the period following the comet's passage, looking for references to the comet or ideas that might have been inspired by it. A young engineer inspired by the comet to develop better detection systems for interstellar objects, a biologist motivated to study extremophiles that might survive interstellar travel, a philosopher prompted to reconsider humanity's cosmic significance. All of these would be ripples from the comet's passage, influences on our timeline mediated through human consciousness. The realm of quantum effects offers perhaps the most speculative but also most fascinating possibilities for the comet's influence. If quantum mechanics truly governs reality at its most fundamental level, then every particle from the comet that interacted with Earth's quantum systems might have caused wave function collapses that wouldn't have occurred otherwise. These quantum events, while individually insignificant, might collectively nudge reality in subtle directions. Consider quantum processes in photosynthesis, where quantum coherence allows plants to harvest light with remarkable efficiency. If particles from the comet interfered with these quantum processes, even briefly, they might have affected plant growth patterns, oxygen production rates, or carbon dioxide absorption. The effects would be impossibly small to measure directly, but they might accumulate over time, potentially affecting weather patterns, atmospheric composition, or ecological relationships. The Earth's magnetic field provides another avenue for investigation. Charged particles from the comet would have interacted with our magnetosphere, potentially causing tiny perturbations that might be recorded in magnetic observatories around the world. These perturbations would be far smaller than those caused by solar storms, but with sensitive enough instruments and sophisticated enough analysis, they might be detectable. Changes in the magnetic field, however small, could affect everything from animal navigation to the rate of cosmic ray influx to Earth's surface. Seismologists might search for correlations between the comet's gravitational influence and seismic activity. While the comet's gravity was far too weak to directly trigger earthquakes, it might have provided the final tiny push needed to trigger events that were already on the verge of occurring. By analysing the timing of seismic events around the world during the comet's passage, scientists might identify statistical anomalies that suggest an influence. Though proving causation would be nearly impossible, the search extends to the astronomical realm as well. The comet's gravitational influence on asteroids and other small bodies in the solar system might have altered their orbits slightly. Over time, these orbital changes could accumulate, potentially affecting the probability of future impacts on Earth or other planets. Astronomers continuously track thousands of near-Earth objects, and subtle changes in their orbits following the comet's passage might be detectable with careful analysis of observational data. We might also look for the comet's influence in the solar wind and the heliosphere, the bubble of charged particles that surrounds our solar system. As the comet passed through this environment, it would have created disturbances like a boat creating a wake in water. These disturbances would propagate outward, potentially affecting the boundary between our solar system and interstellar space. Spacecraft like Voyager 1 and 2, now in interstellar space, might detect echoes of these disturbances years or decades from now. The search for ripples also involves looking at counterfactuals. What didn't happen that might have happened if the comet hadn't passed by? Perhaps an asteroid that would have impacted Earth was nudged into a slightly different orbit. Perhaps a solar flare that would have disrupted satellites was slightly weakened by the comet's influence on the solar wind. Perhaps a mutation that would have occurred didn't, or vice versa. These non-events are impossible to identify with certainty, but they might be the comet's most significant influences. Climate scientists might search for subtle anomalies in weather patterns or climate trends that correlate with the comet's passage. If the comet delivered unusual particles to the upper atmosphere, they might affect cloud formation, albedo, or the greenhouse effect in ways that climate models don't account for. The effects would be tiny compared to human-caused climate change, but they might create small deviations from model predictions that accumulate over time. The field of astrobiology offers particularly exciting possibilities for detecting the comet's influence. If the comet delivered organic molecules or even microorganisms from another star system, they might have properties that make them detectable against the background of Earth life. Perhaps they use slightly different amino acids, or their DNA, if they have DNA, uses different base pairs, or their cell membranes have unusual lipids. The search for such anomalies requires analyzing samples from diverse environments, with techniques sensitive enough to detect trace amounts of unusual biochemistry. Some scientists have proposed that we might detect the comet's influence through its effect on cosmic ray flux. As the comet passed through the solar system, its coma and tail would have scattered some cosmic rays that would otherwise have reached Earth. This temporary reduction in cosmic ray flux might have affected cloud formation, atmospheric chemistry, or even mutation rates in organisms. While the effect would be tiny and temporary, it might have triggered cascading changes that persist to this day. The search for ripples also involves citizen science projects where amateur astronomers, weather observers, and nature enthusiasts contribute observations that might reveal patterns professionals miss. Someone might notice an unusual increase in a certain type of atmospheric phenomenon, a change in animal behavior, or a shift in plant phenology that correlates with the comet's passage. These observations, while anecdotal, can point researchers toward more systematic investigations. We might also search for the comet's influence in human culture and consciousness. Did the comet appear in anyone's dreams? Did it inspire any works of art, music, or literature? Did it influence any important decisions or life changes? These subjective experiences can't be scientifically validated, but they represent real influences on human culture and potentially on our collective future. A poem inspired by the comet might influence someone who influences someone else, creating a chain of causation that extends far into the future. The development of new technologies specifically designed to detect interstellar material might reveal influences we can't currently measure. Imagine sensors that can identify single atoms and determine their origin based on quantum signatures, or detectors that can trace the path of individual cosmic dust particles through the atmosphere, or instruments that can detect the quantum entanglement between particles on Earth and particles from the comet now heading back to interstellar space. As we search for these ripples, we must also acknowledge the possibility that we might never find definitive evidence of the comet's influence. The effects might be too small, too slow, or too complex for our current science to detect. But the search itself has value beyond its potential findings. It pushes us to develop new technologies, to think in new ways, to consider connections we might otherwise overlook. The search for the comet's influence becomes a catalyst for scientific and philosophical advancement. The temporal aspect of the search adds another layer of complexity. Some influences might not become apparent for years, decades, or even centuries. A chemical reaction triggered by molecules from the comet might proceed so slowly that its products won't be detectable for generations. An evolutionary change prompted by the comet might take thousands of years to become fixed in a population. A gravitational perturbation might not cause a significant effect until celestial bodies align in just the right way centuries from now. This means that the search for ripples is not a one-time effort, but an ongoing process that might span generations. Scientists today are laying the groundwork for discoveries that might not be made until long after they're gone. They're establishing baselines, developing techniques, and preserving samples that future researchers will use to identify changes we can't yet detect. It's a beautiful example of intergenerational cooperation, of humanity working together across time to understand our cosmic context. The search also involves looking at different scales of influence. At the quantum scale, we might search for effects on individual particles and wave functions. At the molecular scale, we look for new chemical compounds or reactions. At the cellular scale, we search for biological innovations. At the ecosystem scale, we look for shifts in species distributions or interactions. At the planetary scale, we search for atmospheric or geological changes. At the solar system scale, we look for orbital perturbations. Each scale requires different tools, different approaches, different ways of thinking about influence and causation. We might also search for influences that are not physical but informational. If the comet's passage conveyed information about another star system, through its composition, its orbit, its behavior, then this information has become part of human knowledge. This knowledge might influence future decisions about space exploration, about the search for life, about our understanding of our place in the universe. Information, once gained, can't be ungained. It permanently alters the trajectory of whoever possesses it. The philosophical implications of the search are as important as the scientific ones. By searching for the comet's influence, we're acknowledging that we're not isolated from the cosmos, that we're affected by events far beyond our world. We're recognizing that influence can be subtle and indirect, that small causes can have large effects, that the universe is more interconnected than our everyday experience suggests. The search itself changes how we think about causation, influence, and our relationship with the cosmos. As we continue searching for ripples, we might discover that the most significant influences are the ones we didn't expect. Perhaps the comet's greatest impact was not through the material it delivered or the gravity it exerted, but through the questions it raised, the wonder it inspired, the connections it revealed. Perhaps its influence on Earth's timeline is primarily through its influence on human consciousness, on how we see ourselves and our future. The search for ripples from Comet 3I Atlas is ultimately a search for our cosmic connections, for the threads that bind us to the universe beyond Earth. Every potential influence we investigate, whether we find evidence for it or not, teaches us something about how our world interacts with the cosmos. We're learning about the permeability of Earth's boundaries, the sensitivity of our systems to external influences, the myriad ways that cosmic events can affect planetary evolution. Consider that right now, as you lie there in the darkness, particles that might have come from Comet 3I Atlas are drifting through your room, through your body, becoming part of the air you breathe, the water you drink, the food you eat. You can't see them or feel them, but they're there, silent witnesses to an interstellar journey that ended in our solar system. In a very real sense, you're searching for the comet's influence with every breath you take, every heartbeat that circulates blood that might contain atoms from another star. The search continues in laboratories around the world, where scientists analyze samples with ever-increasing precision, in observatories where astronomers track the orbits of countless objects, in field stations where researchers monitor Earth systems for unusual changes. It continues in the minds of theorists who develop new models of how cosmic influences propagate, in the workshops of engineers who build more sensitive instruments, in the classrooms where students learn about the comet and imagine new ways to detect its influence. We're also searching for ripples in the future, trying to predict what long-term effects the comet might have. Computer models simulate the evolution of the solar system over millions of years, tracking how the tiny gravitational perturbations from the comet might accumulate. Climate models incorporate possible atmospheric changes from comet-delivered material. Biological models explore how new organic molecules might affect evolution. These models can't prove what will happen, but they can suggest possibilities, point us toward what to watch for, help us recognize ripples when they appear. The search for ripples is also a search for meaning. What does it mean if we find evidence of the comet's influence? What does it mean if we don't? Either outcome tells us something important about our place in the universe. If we find influences, it confirms that Earth is not isolated, that we're part of a cosmic web of interactions. If we don't find influences, it might mean that Earth is more resilient than we thought, better insulated from cosmic perturbations, or it might mean that the influences are simply too subtle for our current abilities to detect. As we near the end of our contemplation of searching for ripples, it's worth remembering that the search is not just about Comet 3I Atlas. It's about developing the tools and techniques to detect cosmic influences in general. The next interstellar visitor might have more dramatic effects, or there might be influences from cosmic events we haven't even discovered yet. By searching for ripples from this comet, we're preparing ourselves to understand our cosmic context more fully, to recognize the myriad ways that the universe touches our world. The ripples we're searching for might not be in the physical world at all, but in the realm of possibility. The comet's passage might have shifted the probability distributions that govern future events, making some futures slightly more likely and others slightly less so. These shifts in probability are impossible to measure directly, but they might manifest over time as statistical anomalies, as patterns that don't quite match our predictions, as surprises that in retrospect seem almost inevitable. Our place in the cosmic river becomes clearer as we contemplate our position not as isolated observers, but as participants in a vast flowing system that has been running for billions of years and will continue for billions more. We're not standing on the shore watching the river flow by. We're in the river, part of its substance, shaped by its currents, contributing our own small influences to its flow. Every molecule in our bodies has been part of this cosmic river, cycling through stars and planets and space, and will continue to be part of it long after we're gone. The metaphor of a river is particularly apt because rivers are shaped by everything they encounter. Every rock changes the flow pattern, every tributary adds its waters and sediments, every raindrop contributes to the current. Similarly, our cosmic river, the flow of matter and energy and information through space and time, is shaped by every object it encounters. Comet 3 Atlas was like a small stone dropped into this river, creating ripples that spread outward, interacting with other ripples, contributing to the ever-changing pattern of the flow. Think about Earth's position in this cosmic river. We're not a fixed point, but a swirling eddy, a temporary concentration of matter and energy that maintains its pattern while constantly exchanging material with the flow around it. Every second, cosmic rays pass through us. Solar wind particles bombard our magnetosphere. Photons from distant stars reach our surface. Gravitational waves from colliding black holes slightly squeeze and stretch our planet. We're constantly bathed in cosmic influences, most too subtle to notice, but all contributing to what we are and what we're becoming. The journey of Comet 3 Atlas through our solar system can be seen as a particularly visible example of this constant exchange. For a brief time, material that had been flowing through a different part of the cosmic river entered our eddy, swirled around, left some of itself behind, and continued on its way. It's like two streams briefly merging before separating again, each carrying traces of the other as they continue their journeys. Our solar system itself is not stationary, but is orbiting the center of the Milky Way galaxy at tremendous speed, carrying Earth and all the planets through different regions of space. Right now, we're passing through what's called the local interstellar cloud, a region of relatively dense gas and dust. In about 10,000 years, we'll emerge from this cloud into a different region with different properties. Each region we pass through has its own characteristics, different densities of matter, different radiation levels, different populations of interstellar objects like Comet 3I Atlas. This means that Earth's cosmic environment is constantly changing on timescales that are long by human standards, but brief in cosmic terms. The rate at which we encounter interstellar comets, the flux of cosmic rays, the density of interstellar dust, all of these vary as we journey through the galaxy. Comet 3 Atlas visited us at this particular point in our galactic journey, when we were in this particular cosmic neighborhood with its particular characteristics. Had it arrived 1,000,000 years earlier or later, the encounter would have been different because we would have been in a different part of the galaxy. The spiral arms of our galaxy are regions of increased star formation and stellar density. As our solar system orbits the galactic center, we periodically pass through these spiral arms, experiencing increased rates of cosmic ray flux, more frequent encounters with interstellar objects, and greater gravitational perturbations from passing stars. Some scientists have correlated these passages with mass extinction events on Earth, suggesting that our position in the cosmic river profoundly affects the evolution of life on our planet. We're currently between spiral arms in a relatively quiet region of the galaxy. This might be one reason why complex life has been able to evolve and thrive on Earth. We're in a cosmic calm spot where catastrophic events are relatively rare. But even in this calm region, we're not isolated. Interstellar visitors like Comet 3I Atlas remind us that we're still part of the galactic community, still exchanging material and influences with the cosmos around us. The concept of panspermia, which we've touched on before, takes on new dimensions when we consider Earth's movement through the galaxy. If life or its precursors can travel between star systems on comets and asteroids, then our solar system is both a source and a destination for this cosmic seed dispersal. As we move through different regions of the galaxy, we might encounter biological material from different sources, each potentially contributing to Earth's biosphere in unique ways. Imagine that Earth is like a ship sailing through a cosmic ocean, and comets like 3I Atlas are like messages in bottles from other ships we pass in the night. Most of these messages never reach us, and most of our messages never reach other worlds. But occasionally, like with Comet 3I Atlas, a message gets through. It might be encoded in the comet's chemical composition, in the organic molecules it carries, in the isotope ratios that tell of its origin. We read what we can of the message, add our own observations and interpretations, and the knowledge becomes part of our story. The Oort cloud that surrounds our solar system is like a porous boundary between us and interstellar space. It's constantly losing comets that escape to become interstellar travelers and occasionally capturing objects from other star systems. This exchange means that the Oort cloud is not purely of solar system origin, but contains material from throughout our region of the galaxy. It's a mixing zone where the local and the cosmic blend together. Some of the comets we see as coming from our own Oort cloud might actually be ancient interstellar visitors that were captured millions or billions of years ago. They've been orbiting in the cold darkness so long that we think of them as ours. But they might carry within them the seeds of other star systems, other experiments in planetary formation, other possibilities for chemistry and life. Every comet that falls toward the Sun from the Oort cloud might be delivering this ancient interstellar material to the inner solar system. The cosmic river flows at different speeds at different scales. At the quantum level, changes happen in femtoseconds. At the molecular level, reactions occur in microseconds to minutes. At the biological level, processes unfold over seconds to years. At the geological level, changes take thousands to millions of years. At the astronomical level, processes span millions to billions of years. Comet 3I Atlas connected all these timescales, from quantum events as its molecules absorbed and emitted photons to astronomical processes that brought it from another star system to ours. We humans exist at a particular scale of space and time that allows us to perceive some of these flows but not others. We can watch a river flow and see how it changes over days and seasons, but we can't directly perceive the geological processes that carve the river valley over millions of years. Similarly, we can observe a comet's passage over months, but we can't directly perceive the billions of years of cosmic evolution that brought it to us, or the potential influences it might have over geological timescales. This limitation of perception doesn't mean those other scales don't affect us. The quantum processes happening in our cells right now influence our health and evolution. The geological processes happening beneath our feet shape the landscape we inhabit. The astronomical processes happening in space determine the cosmic environment in which Earth exists. We're influenced by flows at all scales, even those we can't directly perceive. The concept of Earth as part of a cosmic river also helps us understand extinction events and evolutionary jumps. These might be times when the river's flow changes dramatically, when we pass through a spiral arm, when a nearby supernova floods us with radiation, when an asteroid impact suddenly alters the flow pattern. Life on Earth has survived multiple such disruptions, each time adapting, evolving, finding new ways to thrive in the changed conditions. Comet 3 Atlas represents a much gentler perturbation, a small eddy in the cosmic flow rather than a dramatic change of course. But even small eddies can have significant effects if they occur at the right time and place. A tiny change in the flow pattern might direct nutrients to a previously barren area, allowing life to flourish. Or it might disrupt an established pattern, forcing adaptation and evolution. The comet's influence, however small, has become part of the flow pattern that shapes Earth's future. The cosmic river carries not just matter and energy, but also information. Every photon that reaches Earth from a distant star carries information about that star's composition, temperature and motion. Every cosmic ray carries information about the violent events that accelerated it to near light speed. Every gravitational wave carries information about massive objects in motion, and every comet carries information about its origin, its journey, and the conditions it has experienced. This cosmic information flow is constantly updating Earth's database of what exists in the universe. Through the light we receive from distant galaxies, we learn about the universe's past. Through the cosmic rays that bombard us, we learn about high-energy processes happening throughout the galaxy. Through visitors like Comet 3I Atlas, we learn about other star systems and the interstellar medium. Earth is not just a passive receiver of this information, but an active processor of it, especially through the consciousness of life forms that can observe and interpret these cosmic signals. The role of consciousness in the cosmic river is perhaps the most mysterious aspect of our existence. We're not just matter and energy flowing through space and time, we're matter and energy that has become aware of itself, that can observe the flow and wonder about its meaning. Through us, the cosmic river becomes self-aware, able to study itself, to predict its future flow, to potentially alter its course through conscious action. When we detected Comet 3I Atlas, when we studied its composition and trajectory, when we wondered about its effects on our timeline, we were the cosmic river observing itself. The comet wasn't just a chunk of ice and rock passing through our solar system. It was a part of the universe that we, another part of the universe, observed and tried to understand. This self-observation, this self-awareness, might be the most significant aspect of the comet's passage. Not its physical effects, but its contribution to cosmic consciousness. The development of technology has dramatically increased our ability to perceive the cosmic river's flow. Before telescopes, we could only see the brightest celestial objects. Before spectroscopy, we couldn't determine the composition of distant objects. Before computers, we couldn't model complex orbital dynamics. Each technological advance has revealed new aspects of the cosmic flow, new influences we hadn't known existed. Comet 3I Atlas was discovered and studied using technologies that didn't exist even a century ago, revealing cosmic influences our ancestors couldn't have imagined. But technology also changes our relationship with the cosmic river. We're no longer just passive participants in the flow, we're beginning to actively influence it. We've sent spacecraft to other planets, potentially contaminating them with Earth microbes. We've broadcast radio signals that are now dozens of light years from Earth, carrying information about our civilization to any alien observers. We're even beginning to consider technologies that could deflect asteroids or comets, actively altering the cosmic flow to protect our world. This transition from passive to active participation in the cosmic river raises profound questions about our responsibilities and our future. If we can influence the cosmic flow, should we? How do we decide which influences to allow and which to prevent? As we develop more powerful technologies, our ability to affect the cosmic river will grow. We might one day be able to capture interstellar comets for study or resources, to terraform other worlds, to send our own messages to other star systems via artificial comets. The story of Comet 3I Atlas is thus not just about a cosmic visitor that came and went, but about humanity's growing awareness of and participation in the cosmic river. The comet arrived at a pivotal moment in our development, when we could not only detect it, but begin to understand its significance as part of the vast flow of matter, energy, and information that connects all parts of the universe. As we float in this cosmic river, we're beginning to map its currents, to understand its patterns, to predict where it might carry us. We're learning that the river has many scales of flow, from the quantum foam at the smallest scale to the expansion of the universe at the largest. We're discovering that we exist at a special scale, where we can perceive and influence many other scales, where we can be both observers and participants in the cosmic flow. The interstellar medium through which Comet 3 Atlas travelled to reach us is itself a vast, slow-moving river of gas and dust, cycling material between stars. Stars form from this medium, live their lives fusing hydrogen into heavier elements, then return much of their material to the medium when they die. This cosmic recycling has been going on for billions of years, gradually enriching the interstellar medium with heavier elements, making possible the formation of rocky planets and the complex chemistry of life. Our Sun and solar system formed from a region of the interstellar medium that had been enriched by generations of previous stars. The atoms in our bodies have been through this cosmic recycling multiple times, formed in different stars, expelled into space, incorporated into new stars and planets, perhaps even into other life forms on other worlds. We're not separate from the cosmic river. We're temporary arrangements of its substance, patterns that persist for a while before dissolving back into the flow. The cosmic river also flows through dimensions we don't directly perceive. String theory suggests there might be additional spatial dimensions beyond the three we experience. Some theories propose that gravity is weak compared to other forces because it spreads through these extra dimensions. If these theories are correct, then influences might flow through dimensions we can't see, affecting our world in ways we don't understand. Comet 3I Atlas might have created ripples in these hidden dimensions, influences that we can't detect with our three-dimensional instruments. Time itself might be more river-like than we imagine. While we experience time as flowing in one direction, from past to future, physics suggests that time might be more fluid, more complex. Quantum mechanics hints at retrocausality, where future events influence past ones. General relativity shows that time flows at different rates in different gravitational fields. The cosmic river might flow through time in ways that challenge our linear perception, with influences moving upstream as well as downstream, connecting past and future in complex patterns. The anthropic principle, which we've discussed before, suggests that we observe the cosmic river flowing as it does because if it flowed differently, we wouldn't be here to observe it. The precise values of physical constants, the exact history of cosmic events that led to Earth and life, the specific trajectory that brought Comet 3I Atlas through our solar system at just this moment, all of these might be necessary for conscious observers to exist. We're not just in the cosmic river, we're a necessary consequence of its particular flow pattern. But perhaps consciousness is not just a consequence of the cosmic river's flow, but one of its directing forces. Perhaps the universe is evolving toward greater consciousness, greater self-awareness, greater ability to observe and understand itself. In this view, the development of life and intelligence on Earth, our ability to detect and study objects like Comet 3I Atlas, is not accidental, but part of the cosmic river's natural evolution towards self-knowledge. The cosmic river metaphor also helps us understand our future. Rivers eventually reach the sea, and our cosmic river might be flowing towards some ultimate destination we can't yet perceive. Perhaps it's the heat death of the universe, when all energy has been evenly distributed and no more work can be done. Perhaps it's a big rip when dark energy tears apart all structures. Or perhaps it's something we haven't imagined, a transformation of the universe into something completely different. But rivers also have tributaries, branches, deltas, where they split into multiple channels. Our future might not be a single destination, but a branching set of possibilities. The decisions we make, the technologies we develop, the ways we respond to cosmic influences like Comet 3I Atlas, all of these might determine which branch of the cosmic river we follow. We're not just passengers on this river, we're conscious beings who can influence our trajectory, who can choose which currents to follow. The search for life elsewhere in the universe is essentially a search for other conscious points in the cosmic river, other places where the flow has developed self-awareness. If we find such life, whether microbial or intelligent, it will fundamentally change our understanding of our place in the flow. We'll know that consciousness is not unique to Earth, that the cosmic river naturally develops self-awareness in multiple locations, that we're part of a cosmic community of observers. Comet 3I Atlas might have been a messenger from such a community, carrying not a deliberate message but the natural signature of its origin. The organic molecules it contained might be evidence that carbon-based chemistry is common throughout the galaxy. Its trajectory might indicate regions of the galaxy where star systems like ours exist. Its composition might tell us about the variety of cosmic environments where complexity can arise. As we contemplate our place in the cosmic river, it's worth remembering that we've only recently become aware of the river's existence and our position in it. For most of human history, we thought Earth was the center of everything, separate from the heavens. Only in the last few centuries have we realized that we're on a planet orbiting a star in a galaxy, among billions of galaxies. Only in the last few decades have we detected interstellar visitors like Comet 3I Atlas. We're still children learning to perceive the river we've always been part of. The beauty of unanswered questions surrounds us like a gentle mist, inviting us not to despair at what we don't know, but to marvel at the vastness of what remains to be discovered. Comet 3I Atlas came to us bearing questions rather than answers, mysteries rather than revelations, and perhaps that's the greatest gift a cosmic visitor can offer. In a universe where everything was known, where every question had been answered, where every mystery had been solved, there would be no room for wonder, no space for imagination, no reason to look up at the night sky and dream of what might be possible. As you lie there in the darkness, perhaps on the edge of sleep, consider how precious our ignorance is, how valuable our uncertainties, how essential our unanswered questions. Every question we can't answer is an invitation to explore further, to think deeper, to imagine more boldly. Comet 3 Atlas didn't tell us whether it altered our timeline. It invited us to contemplate what it means for a timeline to be altered, what it means to be influenced by cosmic events, what it means to be part of a universe so vast and complex that we can barely begin to comprehend it. The question of whether the comet altered Earth's future timeline might never have a definitive answer, and that's perfectly appropriate. Some questions are more valuable as questions than they would be as answers. They serve as koans for contemplation, as frameworks for investigation, as inspirations for wonder. The question keeps us looking, keeps us thinking, keeps us connected to the cosmic mystery that surrounds us. If we knew for certain that the comet had altered our timeline, or knew for certain that it hadn't, we might stop wondering, stop searching, stop imagining possibilities. Think about all the questions that Comet 3I Atlas raised that we haven't answered. Where exactly did it come from? What star system, if any, was its birthplace? How long had it been travelling through interstellar space? What caused it to be ejected from its original system? How many other star systems had it passed through before reaching ours? What percentage of its original mass did it lose during its passage through our solar system? Where are its fragments now, and where will they be in 1,000,000 years? Did it carry any organic molecules we didn't detect? Did it influence any process on Earth that we haven't noticed? Each of these questions branches into more questions. If we knew what star system it came from, we'd want to know about the planets in that system, whether any of them harbour life, whether they've sent other comets our way. If we knew how long it had been travelling, we'd want to know what the galaxy was like when it began its journey, what cosmic events it might have witnessed, what influences it might have accumulated along the way. Questions beget questions in an endless proliferation of wonder. And then there are the deeper questions that the comet's passage raises about the nature of reality itself. What is time, really, and can the past be changed by events in the present? What is causation, and how do influences propagate through space and time? What is consciousness, and what role does it play in the unfolding of cosmic events? What is information, and how is it encoded in physical objects like comets? What is life, and could it travel between star systems? What is meaning, and who or what assigns it to cosmic events? These questions don't have simple answers, and perhaps they don't have answers at all in the conventional sense. They're questions that each generation of humans must engage with anew, bringing their own perspectives, their own tools, their own insights. The ancient philosophers who first asked these questions didn't have our scientific knowledge, but they had insights we might have lost. Future generations will have tools and knowledge we can't imagine, but they'll still grapple with these fundamental mysteries. The beauty of unanswered questions is that they create space for multiple perspectives, multiple interpretations, multiple possibilities. If we knew exactly how Comet 3I Atlas had influenced our timeline, there would be only one story to tell. But because we don't know, there are infinite stories, infinite possibilities, infinite ways to imagine the comet's significance. Each person who contemplates the comet creates their own meaning, their own understanding, their own relationship with this cosmic visitor. Scientists approach the comet's mysteries with hypotheses and experiments, trying to narrow down the possibilities through observation and analysis. Artists approach them with imagination and creativity, exploring the emotional and aesthetic dimensions of our cosmic encounter. Philosophers approach them with logic and speculation, probing the implications for our understanding of existence. Children approach them with wonder and curiosity, asking questions that adults might not think to ask. Each approach reveals different facets of the mystery, different aspects of the truth. The unanswered questions about Comet 3 Atlas connect us to the larger mystery of existence itself. Why is there something rather than nothing? Why does the universe exist at all? Why does it have the particular laws and constants that it does? Why did life emerge? Why did consciousness develop? These are questions that might never have final answers, but engaging with them is part of what makes us human, part of what gives our existence meaning and depth. In many spiritual traditions, mystery is not a problem to be solved, but a reality to be experienced. The mystical experience is precisely the encounter with that which cannot be fully understood or explained, that which transcends our categories and concepts. Comet 3I Atlas offers us a small taste of this cosmic mystery, a reminder that we live in a universe far stranger and more wonderful than our theories can capture. The comet's fragmentation provides a beautiful metaphor for how mysteries unfold. When we first detected the comet, it seemed like a single, simple object with a straightforward story. But as it approached the sun and broke apart, it revealed its complexity, its heterogeneity, its hidden structure. Each fragment told a slightly different story, revealed a different aspect of the comet's nature. Similarly, as we investigate cosmic mysteries, they often fragment into multiple mysteries, each more complex than the original question. Consider how our understanding of the comet has evolved and will continue to evolve. The data we collected during its passage will be reanalyzed with new techniques, revealing details we missed the first time. New theories will be proposed to explain its behavior. Future interstellar visitors will be compared to it, perhaps revealing that it was typical or unusual in ways we couldn't know from a single example. Decades from now, scientists might look back at our current understanding and smile at how much we didn't know, just as we look back at earlier generations' understanding of comets. This evolution of understanding doesn't mean that our current knowledge is worthless, or that there's no point in trying to understand things now. Each generation builds on the work of previous ones, adding layers of understanding, correcting errors, opening new avenues of investigation. Our observations of Comet 3I Atlas, however incomplete, are now part of the permanent scientific record, available for future researchers to build upon. We're contributing to a multi-generational project of cosmic understanding. The beauty of unanswered questions also lies in their ability to inspire. How many young people learned about Comet 3I Atlas and were inspired to study astronomy, or physics, or chemistry, or biology? How many were motivated to think about humanity's future in space, about the possibility of life elsewhere, about our cosmic origins and destiny? Each unanswered question is a seed that might grow into a lifetime of investigation, a career of discovery, a contribution to human knowledge. The questions raised by the comet also have practical implications that might shape our future. If interstellar comets can deliver organic molecules to planets, should we be looking for signs of life in different places? If they can alter planetary timelines through subtle influences, should we be monitoring them more carefully? If they're more common than we thought, should we be preparing to study or even capture future visitors? These questions influence funding decisions, research priorities, and technological development. But perhaps the most beautiful aspect of unanswered questions is how they keep us humble. Despite all our scientific achievements, despite our powerful telescopes and sophisticated theories, a simple comet can still surprise us, still raise questions we can't answer, still remind us how much we don't know. This humility is not weakness but strength, not ignorance but wisdom. It keeps us curious, keeps us searching, keeps us open to new possibilities. The mystery of whether Comet 3I Atlas altered Earth's timeline is nested within larger mysteries. Even if we could definitively answer this specific question, it would immediately raise others. If the comet did alter our timeline, how many other cosmic events have done the same? If it didn't, what would it take for a cosmic event to have a detectable influence? Either answer would deepen rather than resolve the fundamental mystery of our cosmic context. The tradition of negative theology, or apophatic theology, suggests that the divine can only be described by what it is not, that the ultimate reality transcends all positive descriptions. Similarly, we might practice a kind of negative cosmology, recognizing that the universe transcends our ability to fully describe or understand it. We can say what the universe is not. It's not simple, it's not isolated, it's not static, but capturing what it is remains beyond our reach. This doesn't mean we should stop trying to understand, stop asking questions, stop searching for answers. The quest for understanding is valuable even if, especially if, it never reaches a final destination. The journey of discovery, the process of investigation, the experience of wonder, these are their own rewards. Comet 3I Atlas gave us an opportunity to engage in this quest, to be part of this journey, to experience this wonder. The unanswered questions about the comet also connect us across time. Ancient humans who saw comets in the sky and wondered about their nature were engaging with the same fundamental mysteries we engage with today. Future humans who detect interstellar visitors we can't imagine will still be grappling with questions of origin, influence, and meaning. The questions transcend individual lives, connecting us to a conversation that has been going on since consciousness first emerged and will continue as long as conscious beings exist. In the quantum mechanical view of reality, unanswered questions might be more than just gaps in our knowledge. The act of observation collapses quantum superpositions into definite states, but until that observation, all possibilities coexist. Perhaps cosmic events like the passage of Comet 3 Atlas exist in a superposition of influences until we observe their effects. The unanswered questions maintain this superposition, keeping all possibilities alive, all futures potential. This quantum perspective suggests that unanswered questions are not just about what we don't know, but about what hasn't yet been determined. The comet's influence on our timeline might still be forming, still be crystallizing out of the quantum foam of possibilities. By wondering about it, thinking about it, looking for its effects, we might be participating in the process that determines what those effects will be. The questions themselves might be part of the answer. The beauty of unanswered questions is also in their democracy. While experts might have more detailed knowledge about comets and orbits and spectroscopy, the fundamental questions raised by Comet 3I Atlas are accessible to everyone. A child wondering where the comet came from is engaging with the same mystery as a professional astronomer. An artist imagining the comet's journey is exploring the same unknown as a physicist calculating its trajectory. The questions belong to all of us. Different cultures might interpret the comet's mysteries through different lenses, bringing their own mythologies, philosophies, and ways of knowing to bear on the questions. Indigenous peoples with deep astronomical traditions might see patterns and meanings that Western science overlooks. Eastern philosophies might offer insights into the nature of change and influence that complement scientific analysis. The diversity of human perspectives enriches our engagement with cosmic mysteries. The comet's unanswered questions also remind us of the limits of different ways of knowing. Science can tell us the comet's composition and orbit, but not its meaning. Philosophy can explore its implications, but not predict its physical effects. Art can capture its beauty and mystery, but not calculate its mass. Each way of knowing illuminates some aspects while leaving others in shadow. The full truth, if such a thing exists, requires all ways of knowing, and probably some we haven't discovered yet. As we near the end of our contemplation, it's worth reflecting on how the unanswered questions about Comet 3I Atlas mirror the unanswered questions about our own lives. Where did we come from ultimately? What influences shaped us into who we are? What effects will our lives have on the future? What is our purpose, our meaning, our significance? These personal mysteries resonate with the cosmic mysteries, suggesting that we're not separate from the universe but expressions of its tendency toward complexity, consciousness, and questioning. The comet came and went, leaving us with more questions than answers, and that's exactly as it should be. If cosmic visitors arrived with clear messages, unambiguous influences, and definitive answers, they would rob us of the opportunity to wonder, to investigate, to imagine. The mystery is not a barrier to understanding, but an invitation to engage more deeply with the cosmos and our place in it. Think about how different our relationship with the universe would be if we had all the answers. There would be no reason to build better telescopes, no motivation to develop new theories, no inspiration for cosmic poetry or art. The unanswered questions are what keep us reaching toward the stars, literally and figuratively. They're what make us human, not the answers we have, but the questions we ask. Comet 3I Atlas has joined the pantheon of cosmic mysteries that define our era. Like dark matter and dark energy, like the nature of consciousness and the origin of life, like the possibility of other universes and other dimensions, the question of the comet's influence on our timeline is now part of our cultural and scientific heritage. Future generations will inherit this question, along with whatever partial answers we manage to find. But they'll also inherit the wonder, the curiosity, the sense of cosmic connection that the comet inspired. They'll know that in 2019 and 2020, humans on Earth detected and studied a visitor from another star system, that we wondered about its effects on our world, that we saw ourselves as part of a vast cosmic story still being written. This knowledge, this perspective, this wonder might be the comet's most lasting influence on our timeline. The beauty of unanswered questions is that they remain alive, dynamic, evolving. Unlike answered questions that become fixed facts, unanswered questions continue to grow, to spawn new questions, to inspire new thoughts. The mystery of Comet 3I Atlas is not a static puzzle waiting to be solved, but a living question that will evolve as we evolve. that will mean different things to different generations, that will continue to inspire wonder as long as humans look up at the night sky. As you drift towards sleep, carried by these thoughts of cosmic mystery and wonder, remember that you yourself are an unanswered question. Your consciousness, your experience, your impact on the world, these are mysteries as profound as any comet's journey. You're made of stardust, influenced by cosmic forces, participating in the universe's attempt to understand itself. The questions you ask, the wonder you feel, the connections you make, these are all part of the cosmic story, part of the ongoing creation of meaning in a universe that seems equally capable of profound significance and complete indifference. The comet has gone, continuing its journey into the darkness between stars, carrying with it whatever secrets it didn't share with us. But it left us with something perhaps more valuable than answers. It left us with beautiful questions, with reasons to wonder, with connections to the cosmos that we might not have felt otherwise. It reminded us that we're not alone in the universe, that visitors from other star systems occasionally grace our skies, that we're part of an exchange of matter and energy and information that spans the galaxy. In the end, the beauty of unanswered questions is that they connect us to the infinite. Every question opens onto other questions in an endless regression that ultimately encompasses everything, every star, every atom, every thought, every possibility. Comet 3I Atlas was a small window into this infinite mystery, a brief glimpse of the vastness that surrounds us and fills us and is us. The fact that we can ask questions about it, wonder about it, search for its influence, imagine its significance. This is the miracle, this is the gift, this is the beauty that transcends all answers. The universe doesn't owe us answers, it doesn't owe us meaning or purpose or significance. But it has given us something perhaps more precious, the ability to question, to wonder, to imagine, to create meaning through our engagement with mystery. Comet 3 Atlas was an invitation to exercise these abilities, to join the cosmic conversation, to add our voices to the chorus of consciousness that might, for all we know, span the galaxy or even the universe. As sleep approaches, as your consciousness prepares to slip into dreams where logic loosens and possibilities multiply, carry with you the questions the comet raised. Let them percolate through your sleeping mind, mixing with your own mysteries, your own wonders, your own unanswered questions. Perhaps in dreams, where the boundaries between self and cosmos dissolve, you'll find not answers but deeper questions, not solutions but richer mysteries, not certainty but more beautiful uncertainty. The story of Comet 3I Atlas is far from over. It continues in every particle of comet dust drifting through our solar system, in every scientific paper analysing its data, in every person who learned about it and wondered. It continues in the questions we ask and the questions we haven't thought to ask yet. It continues in the future influences it might have that we can't yet detect or imagine. And it continues in you, in your awareness of it, in your contemplation of its meaning, in the synaptic patterns of your brain that formed as you thought about this cosmic visitor. Did Comet 3 Atlas alter Earth's future timeline? The question remains beautifully, mysteriously, wonderfully unanswered. And in that space of not knowing, in that openness to possibility, in that humble acknowledgement of the vastness of what we don't understand, we find not frustration but freedom, not emptiness but potential, not endings but beginnings. The comet came to us as a question mark written across the sky, and we're all the richer for the mystery it brought. Sleep now, if sleep is coming, and let the unanswered questions be your companions in the darkness. They're not burdens but gifts, not problems but invitations, not barriers but doorways to wonder. And tomorrow, when you wake, the questions will still be there, still beautiful, still unanswered, still connecting you to the cosmic mystery that surrounds us all. The comet has gone, but the wonder remains, and that wonder is perhaps the most precious thing in the universe, the capacity of matter to contemplate itself, to question its own nature, to search for meaning in the vast darkness, and occasionally, gloriously, to find not answers but even more beautiful questions. The universe whispers its secrets through comets and stars, through quantum fluctuations and gravitational waves, through the emergence of life and consciousness. We're still learning to hear these whispers, still developing the ears to listen, the minds to comprehend, the hearts to appreciate the beauty of cosmic mystery. Comet 3 Atlas was one such whisper, a gentle murmur from the depths of space and time, telling us not what to think but that we can think, not what to know but that we can wonder, not what we are but that we are, here, now, part of something magnificent and mysterious and ongoing. And so our contemplation comes full circle, like the orbits that govern celestial mechanics, like the cycles that govern cosmic evolution, like the questions that return again and again in different forms but always pointing toward the same infinite mystery. We began by wondering if a comet altered our timeline, and we end by realizing that the wondering itself is the alteration, the question itself is the influence, the mystery itself is the gift. In a universe where such wonders are possible, where consciousness can contemplate comets, where finite beings can ponder infinity, where questions can be more valuable than answers, we're all blessed, all fortunate, all part of something beautiful beyond words. The night deepens, the stars wheel overhead, and somewhere in the darkness the fragments of Comet 3 Atlas continue their eternal journey. They carry with them the memory of their brief encounter with our sun, the ghost of their ancient origin, the potential for future influences we can't imagine. And we carry within us the memory of their passing, the questions they raised, the wonder they inspired. We're connected now, we and the comet, bound together by the threads of observation and contemplation, influence and wonder, matter and meaning. Rest now in the beauty of unanswered questions, in the peace of accepted mystery, in the quiet joy of being part of a universe so vast and complex and wonderful that we'll never run out of things to discover, never exhaust the possibilities for wonder, never reach the end of questions. This is our cosmic inheritance, our place in the great story, our role in the universe's attempt to know itself. And it all continues tomorrow, and the day after, and for as long as conscious beings exist to look up at the sky and wonder what it all means, where it's all going, and whether a comet from another star might have changed everything in ways we're only beginning to imagine.